we now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. This question is based on the concepts that the student has learnt in +2 level, and it depends on the basic mathematics of +2 level. And this question is categorized under the section Matrices and Determinants. The given question is, let f of x is equal to, it is given as a 3 by 3 determinant whose first row is a minus 1, 0, second row ax, a minus 1, third row ax square, ax, a, where a is a real number. Then the sum of the squares of all values of a for which 2 times f prime 10 minus f prime 5 plus 100 is equal to 0 is, we are given 4 options. Option A 117, option B 106, option C 125, option D 135. We are given a function f of x as a 3 by 3 determinant like this, where a is a real number. Then required to find the sum of the squares of all values of a for which this relation holds good. That is the given question to us. Let's now discuss the solution of the problem in detail. We have f of x given as a 3 by 3 determinant whose first row is a minus 1, 0, second row ax, a minus 1, third row ax square, ax, a, where a is a real number. Observe that in this determinant, the a is common. A is appearing in every entry of the first column. By the properties of the determinants, this a will come out. So a is common. A times the determinant, the first column is 1x, x square. Second column is minus 1 ax, and the third column is 0 minus 1 a. 0 minus 1 a. Now expand this determinant by its first row. We are very familiar with the expansion of the determinants, and we get that's equal to a into, in brackets, 1 into a plus ax minus of minus 1, that is plus 1 of ax plus x square. Agreed. Now get inside the bracket, a square plus ax, that is plus 2ax plus x square, that is a square plus 2ax plus x square, that is a plus x whole square in brackets, and that will be equal to a times a plus x whole square. Good. Now therefore f of x is a into a plus x whole square. Its first derivative, f prime x, is equal to 2a into a plus x. Right. So what's that we want? We find the sum of the all values of a for which this relation holds good. That is 2 times f prime 10 minus f prime 5 plus 100 is equal to 0. Let's call this as the relation 1 and call this as the equation 1. Agreed. We continue in the next slide. That's what we have done so far. So we take the relation and substitute for f prime 10 and f prime 5 and f prime 5 and simplify. 2 times f prime 10 is equal to 2 into f prime 10 is 2a into a plus 10 minus f prime 5 is 2a into a plus 5, 2a into a plus 5 plus 100 is equal to 0. Agreed. Simplify. 2 into 2a, 4a square plus 40a minus 2a square minus 10a plus 100. Now simplify further. So 4a square minus 2a square is 2a square. 40a minus 10a is 30a plus 100. Now we see 2 is common in this equation. Therefore, cancel out that one. We get a square plus 15a plus 50 is equal to 0. Look at 50. 50 is factorized as 5 into 10 and 5 plus 10 is 15. Therefore, factorization is very easy. This will imply a plus 5 into a plus 10 is equal to 0. That will give rise to a is equal to minus 10 or minus 5. We will now answer the question. The sum of the squares of all values of a, for which the equation 1 is satisfied, is given by minus 10 square plus minus 5 square. That is 100 plus 25. That is 125. Let's look at our options. Our answer 125, which is the sum of the squares of all values of a for which the equation 1 is satisfied, appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem, which is based on the knowledge of basic mathematics at +2 level, and it is categorized under the section matrices and determinants. And I make a comment that it is a very, very, very easy, simple and straightforward question. And once in a time, such questions do occur, but not always. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We will now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is related to the tautology of the given 4 logical statements, and this question is from the section Mathematical Reasoning. This question is from the section Mathematical Reasoning. The given question is, which of the following statement is a tautology? We are given 4 statements. Option A in brackets, negation of Q and P and Q. Option B, in brackets, negation of Q and P, and in brackets, P and negation of P. Option C, in brackets, negation of Q and P, or in brackets, P or negation of P. Option D, in brackets, P and Q, and in brackets, negation of P and Q. Now we have to find that statement which is a tautology from the given 4 options. Before entering into the discussion of the solution of the problem, let us recall the definitions of tautology, contradiction, and contingency. Tautology. A compound proposition is called a tautology if it is always true for all possible truth values of its variables. Agreed? And the example is P or negation of P will be true always for all truth values of P. Contradiction is also called fallacy. A compound proposition is called a contradiction or a fallacy if it is always false for all possible truth values of its variables. Example, P and negation of P it will be always false for all truth values of P. Contingency, a statement which is neither a tautology nor a contradiction, is called a contingency. That means it takes at least one truth value true and the other truth value false at least once. Example, P and Q. Agreed. We go to our given question and discuss. Let us take first the option A. The statement given is negation of Q and P in brackets and Q. Agreed. We use commutative law and to bring this Q to the front. So we use commutative law. If you use commutative law, this is equivalent to, logically equivalent to Q and in brackets negation of Q and P. We use associative law and we associate these two variables. We use associative law, it's logically equivalent to Q and negation of Q and P. Recall, Q and negation of Q is a contradiction. That means it will be always false for all possible truth values of P. So this is equivalent to F and P. And F and P, for all truth values of P, it will be F. It will be false. That means for all truth values of P and Q, the given statement is false. That means it is a contradiction. That means the given statement is not a tautology. On the other hand, it is a contradiction. Agreed. We move to option B. Option B says, in brackets, negation of Q and P, and in brackets, P and negation of P. Look at this one, P and negation of P. This is a contradiction. So this will be always false for all truth values of P. So this is equivalent to the first one is in brackets negation of Q and P and F. And now recall P and F. P and F is F always for all truth values of P. Therefore, it is F. That means for all truth values of P and Q, it will be false. That means it is a contradiction and it is not a tautology. So the given expression is not a tautology and it is a contradiction. Let's move to option C. In brackets, negation of Q and P are, in brackets, P or negation of P. Look at this. This is a tautology. So this is T for all truth values of P. So this is equivalent to the first one as it is RT. And recall, for any truth value of P, P RT is logically equivalent to T. So it is T. So that means it is true. It is true for all possible truth values of P and Q. Therefore, it is a tautology, and that's our answer. Option D. P and Q in brackets and in brackets negation of P and Q. Now this is one statement. It is one statement. Let's say P and Q, one statement and negation of that statement. So P and negation of P is F. That is a contradiction. There's a contradiction and hence it will take false F. It will be always false for all truth values of P and Q. Agreed. So that means it is not a tautology and it is a contradiction. Now the answer to this question is that the option C is a tautology. So the answer is option C. So that is the detailed discussion of the solution of the problem from the section Mathematical Reasoning, and the question is based on the concepts of tautology and contradiction. And it is a very simple and straightforward problem, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section Matrices and Determinants, and the problem is on the determinant of the adjoint of a given matrix capital X and related to it. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let capital A and B be two 3x3 matrices such that AB, the product, is equal to the identity matrix, and determinant of A is equal to 1/8. Then determinant of adjoint of B times adjoint of 2A is equal to, we are given four options. Option A 16, option B 32, option C 64, option D 128. We have two matrices capital A and B of the same order 3, and they are given such that the product AB is equal to the identity matrix and the determinant of A is equal to 1/8. You are asked to find the value of the determinant of adjoint of B multiplied by adjoint of 2A is equal to. That is the given question to us. We now discuss the solution of the problem in detail. We are given two 3x3 matrices capital A and capital B such that the product AB is equal to the identity and the determinant of A is equal to 1/8. Right. Now, what is the determinant of B? That is the first question we are asking. So we take AB is equal to I. Take the determinants on both sides. Determinant of AB is equal to determinant of I. Determinant of I is 1. Determinant of AB is equal to determinant of A into determinant of B, provided if they are square matrices of the same order. Let's recall. Let X and Y be square matrices of order n, then determinant of xy is equal to determinant of x into determinant of y. Therefore, determinant of AB is equal to determinant of A into determinant of B is equal to 1. This will imply determinant of B is equal to 1 by determinant of A, but determinant of A is 1/8. Therefore, 1 by determinant of A is 8. Thus, we got determinant of B is equal to 8. Agreed. Let's go to the question. Now, determinant of adjoint of B multiplied by adjoint of 2A is equal to. Now, we recall the adjoint of X, where X is a square matrix of order n, is equal to determinant of X to the power of n minus 1. So, the adjoint of the matrix B multiplied by adjoint of 2A is equal to This is the adjoint of this matrix. Therefore, the matrix determinant of that matrix to the power of n minus 1, where n is here 3. So it is determinant of the matrix B into adjoint of 2a to the power of n minus 1, and we are working out with the square matrix of order 3, therefore 3 minus 1. So 3 minus 1 will be square. It is determinant square. Agreed. Now, what is the determinant of B times adjoint of 2a? Adjoint of 2a is another matrix, B into some other matrix. And we recall determinant of xy is equal to determinant of x into determinant of y. Therefore, it is determinant of B into determinant of adjoint of 2a whole to the power of square. So that is equal to determinant of B multiplied by adjoint of 2a for this. For this is the determinant of the product. So product of their determinants whole square. This square is as it is. Agreed. Now again for the determinant of adjoint of a matrix is equal to the determinant of that matrix to the power of n minus 1. So the adjoint of 2a determinant is determinant of 2a to the power of 3 minus 1 whole square. So you are repeatedly using these results. Agreed. Now what is the determinant of 2a? Determinant of 2a. So we have determinant of k times x, where k is a scalar, is k power n into determinant of x, where n is the order of the matrix x. Here the order of the matrix A is 3. Determinant of 2a is 2 cube into determinant of a whole square, and again outside a square. So be careful. So it is determinant of B into determinant of 2a whole square is here, this square is here, and 2a is 2 cube into determinant of a, and this is square. So k power n is 2 power 3. N is the order. Agreed. Now what is determinant of a? Determinant of a is 1 by 8. You can straight substitute here. So determinant of b is 8 multiplied by 2 cube into determinant of a is 1 by 8 whole square. Be careful about these things. Agreed. 2 cube into 1 by 8 is 1. So it is 8 square only, that is 64. Thus the answer for the determinant of adjoint of b time b multiplied by adjoint of 2a is 64. So let's look at our options. Our answer 64 appears against option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of the problem on the concept of the determinant of adjoint of a given matrix from the section Matrices and Determinants. And it is a very simple and straightforward question. It is in fact a similar type of questions have already appeared in the previous question papers. So it's almost a question which is almost repeated under a different setting. Agreed. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is from the section Sequences and Series, and the problem is based on the concepts of arithmetic progressions. The given question is if A1, A2, A3, etc. and B1, B2, B3, etc. are in arithmetic progression and A1 is equal to 2, A10 is equal to 3, A1 B1 is equal to 1 is equal to A10 B10, then A4 multiplied by B4 is equal to, we are given 4 options. Option A 35 by 27, option B 1, option C 27 by 28, option D 28 by 27. We are given 2 arithmetic progressions. The first one is A1, A2, A3, etc. The second one is B1, B2, B3, etc. It is further given A1 is equal to 2, A10 is equal to 3 and A1, B1 is equal to A10, B10 is equal to 1. Required to find the value of A4 multiplied by B4. Let's now find out the detailed solution of the given problem. We are given the first arithmetic progression A1, A2, A3, etc. With the first term A1 is equal to 2, the 10th term A10 is equal to 3. The second arithmetic progression B1, B2, B3, etc. Further it is given A1, B1 is equal to 1 is equal to A10, B10. So A1, B1 is equal to 1 will imply B1 is equal to 1 by A1. A1 is 2, that is equal to 1 by 2. A10, B10 is 1 will imply B10 is equal to 1 by A10. A10 is 3, that is equal to 1 by 3. B10 is 1 by 3. So, let and required to find A4 multiplied by B4. And to find A4, B4, we need the common differences of the first AP and the second AP. For that, we let D1 and D2 be the common differences of the first AP, A1, A2, A3, etc. and the second AP, B1, B2, B3, etc. respectively. Now, A10 is equal to, we know, A1 plus 10 minus 1 into D1, because the nth term of an arithmetic progression whose first term is A1 and common difference is D1 is given by An is equal to A1 plus n minus 1 into D1. Agreed. This will imply A10, we know that it is 3, is equal to A1, it is 2, plus 9 D1. D1 we do not know, required to find. This will imply 9 D1 is equal to 1. Therefore, we get D1 is equal to 1 by 9. So thus, the first arithmetic progression, that is A1, A2, A3 is completely known. Let us take the second one. B10 is equal to B1 plus 9 D2. Correct. B10 is 1 by 3. B1 is 1 by 2. So 1 by 3 is equal to 1 by 2 plus 9 D2. That will give you 1 by 3 minus 1 by 2 is equal to 9 D2. That will give you 9 D2 is equal to minus 1 by 6 after taking the LCM and simplifying. Therefore, D2 is equal to minus 1 by 6 into 9, that is 54, minus 1 by 54. Thus, the second, the arithmetic progression B1, B2, B3 is completely known. Now we are ready to compute A4 multiplied by B4, that is what is wanted in the question. Therefore, A4 multiplied by B4, A4 is A1 plus 3D1, the fourth term of the first AP. B4 is the fourth term of the second AP. B1 plus 3D2. A1, you know 2. D1 is 1 by 9. B1 is 1 by 2. D2 is minus 1 by 54. So substitute these values and simplify. This will be equal to 2 plus 3 into 1 by 9 is 1 by 3 multiplied by 1 by 2. 3 into minus 1 by 54 is minus 1 by 18. Take the LCM. You will get 6 plus 1 by 3 multiplied by 9 minus 1 by 18. And that will be 7 by 3 into 8 by 18. This 8 by 18 is same as 4 by 7. That is 4 by 9. Cancelling 2 in both in the numerator and denominator. You will get 4 by 9. 4 into 7, 28 by 9 into 3, 27. So 28 by 27. A4 multiplied by B4 is equal to 28 by 27. Let's look at our options. Our answer 28 by 27 appears against option D. Therefore, the answer to this question is option D. That is the detailed discussion of the solution of the problem from the section sequence and series. And the question is based on the concepts of arithmetic progression. And it is a very simple and straightforward question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. This problem is from the section Trigonometry, and it is on the concepts of inverse trigonometric functions. The given question is the value of cot of in brackets sigma n is equal to 1 to 50 tan inverse in brackets 1 by 1 plus n square is, we are given four options. Option A 26 by 25, option B 25 by 26, option C 50 by 51, option D 52 by 51. Required to find the value of cot of in brackets sigma n is equal to 1 to 50 tan inverse of 1 by 1 plus n square is. That's the given question to us. Let's now discuss the solution of the problem in detail. We take first tan inverse of 1 by 1 plus n square. That is equal to tan inverse of 1 by 1 plus n square. We have taken n common, so we'll get n into n plus 1. So tan inverse of 1 by 1 plus n into n plus 1. This 1 is written as n plus 1 minus n. So tan inverse of n plus 1 minus n by 1 plus n into n plus 1. Recall a formula. The formula is tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy when xy greater than minus 1. Now we apply this formula in the reverse way. Tan inverse of x minus 1 y by 1 plus xy is tan inverse x minus tan inverse y. For this we write tan inverse of n plus 1 minus tan inverse of n, and the condition is automatically satisfied in this case. N is a natural number coming from 1 to 50, and n into n plus 1 is always greater than minus 1. Therefore, the condition is trivially true in this case. So we get this one. Now take the sigma n is equal to 1 to 50. Tan inverse of 1 by 1 plus n square is equal to sigma n is equal to 1 to 50. Tan inverse of 1 by 1 plus n square we have already seen above. Tan inverse of n plus 1 minus tan inverse of n in brackets. Right. Now expand. That's equal to, when n is equal to 1, then you will get tan inverse 2 minus tan inverse 1. N is equal to 2, tan inverse 3 minus tan inverse 2. N is equal to 4, tan inverse 4. N is equal to 3, n is equal to 3, yes, tan inverse 4 minus tan inverse 3, so on so forth. And when n is equal to 49, tan inverse 50 minus tan inverse 49. Lastly, when n is equal to 50, tan inverse 51 minus tan inverse 50. Now we see tan inverse 2 cancels. This is telescoping series, finite series, telescoping series. So in that the salient property is tan inverse 2 cancels with this tan inverse 2. Tan inverse 3 cancels with this tan inverse 3. And tan inverse 4, the next bracket. And tan inverse 49, a bracket before that. And we are left with lastly tan inverse 50 cancels with tan inverse 50. In telescoping like this, the answer will be the last term which is surviving minus the first term. So that is equal to tan inverse 51 minus tan inverse 1. Now again we apply tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy. So that will be equal to tan inverse of 51 minus 1 by 1 plus 51 into 1. X is 51, y is 1. So this will be tan inverse 51 minus 1 is 50 by 52. Tan inverse 50 by 52. There is a common factor 2 both in the numerator and denominator cancel. Tan inverse of 25 by 26. Now go back to the given question. Therefore cot of sigma n is equal to 1 to 50 tan inverse of 1 by 1 plus n square is equal to cot of this sigma. We have already seen it is tan inverse 25 by 26. So the cot of tan inverse 25 by 26, and that is equal to 1 by tan of tan inverse 25 by 26. Yes, and it will be 1 by 25 by 26, and reverting this one will get 26 by 25. So the cot of sigma n is equal to 1 to 50 tan inverse of 1 by 1 plus n square is coming out to be 26 by 25. Let us look at our options. Our answer 26 by 25 appears against option A. The answer to this question is option A. And that is the detailed discussion of the solution of the problem which is based on the concepts of inverse trigonometric functions from the section Trigonometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. This question is from the section Complex Numbers and Quadratic Equations, and this question is on the roots of quadratic equations. The given question is, let alpha, beta be the roots of the equation x square minus 4 lambda x plus 5 is equal to 0, and alpha, gamma be the roots of the equation x square minus, in brackets, 3 under the square root of 2 plus 2 under the square root of 3 x plus 7 plus 3 lambda under the square root of 3 is equal to 0, where lambda greater than 0. If beta plus gamma is equal to 3 root 2, then in brackets alpha plus 2 beta plus gamma whole square is equal to. We are given two quadratic equations. This is the first quadratic equation, and the second quadratic equation is here. And it is given alpha, beta are the roots of this first quadratic equation, and alpha, gamma and gamma are the roots of the second quadratic equation, where lambda is given to be greater than 0. Further, you are given beta plus gamma is equal to 3 root 2, then required to find the value of alpha plus 2 beta plus gamma whole square. That is the given question to us. Let us now discuss the solution of the problem in detail. Given alpha, beta are the roots of the first quadratic equation x square minus 4 lambda x plus 5 is equal to 0, where lambda is greater than 0. It is known that the sum of the roots alpha plus beta is equal to minus the coefficient of x by the leading coefficient, that is the coefficient of x square. And alpha beta is equal to the constant term by the leading coefficient. With that, alpha plus beta is equal to 4 lambda. Let's call that as the equation 1. Alpha beta, the product of the roots, is equal to 5. Let's call this as the second equation. We are also given alpha, gamma are the roots of the second quadratic equation x square minus, in brackets, 3 under the square root of 2 plus 2 under the square root of 3 x plus 7 plus 3 lambda root 3 is equal to 0. And alpha plus gamma is equal to 3 root 2 plus 2 root 3, following the same principle, that is the coefficient minus the coefficient of x by the leading coefficient, and the product of the roots alpha gamma is equal to the constant term by the leading coefficient, that is 7 plus 3 lambda root 3. This is the third equation. This is the fourth equation. Agreed. It is further given to us beta plus gamma is equal to 3 under the square root of 2. Call this as the equation 5. What is that we want? We want to find the value of alpha plus 2 beta plus gamma whole square. Now from equation 1 we have alpha plus beta. From equation 5 we have beta plus gamma. If you add these two things, you will get alpha plus 2 beta plus gamma. So adding 1 and 5, equation 1 and 5, alpha plus beta plus gamma is equal to, alpha plus beta is 4 lambda and beta plus gamma is plus 3 root 2. So it is alpha plus 2 beta plus gamma is equal to 4 lambda plus 3 root 2. Let's call this equation 6. Now if you square it, you will get alpha plus 2 beta plus gamma whole square, provided if you know the value of lambda. So the problem reduces to find the value of lambda. Take that lambda, substitute here and square it, you will get your answer. So our search is to find lambda. That we will do in the next slide. Now those equations 1 to 6 what we have are here. Now we take the equation 1 and 5, subtract 5 from 1, then alpha plus beta minus gamma, beta cancels and you will get alpha minus gamma. So from the equation 1 subtract the equation 5, then you will get alpha plus beta minus gamma, that is alpha minus gamma, is equal to, so alpha plus beta minus beta plus gamma, so that is alpha minus gamma, and that is 4 lambda minus 3 root 2. In the equation 1 4 lambda is there, in equation 5 3 root 2 is there. So alpha minus gamma is equal to 4 lambda minus 3 root 2. Let's call this as the equation 7. We know alpha plus gamma from the equation 3. If we add, you will get 2 alpha in terms of lambda. And from that gamma also you can get the values. So let's see. So 3 plus 7, equation 3 and 7. In equation 3 we have alpha plus gamma. In equation 7 we have alpha minus gamma. So if we add, gamma cancels and 2 alpha is equal to 3 root 2 plus 2 root 3, that of alpha plus gamma, and plus 7. In the equation 7 4 lambda minus 3 root 2 is there, 4 lambda minus 3 root 2. 3 root 2 cancels, you will get 4 lambda plus 2 root 3. This is 2 alpha. So then alpha will be cancelled 2 throughout, you will get 2 lambda plus root 3. You will get 2 lambda plus root 3. Alpha value we got. So go to equation 1 and obtain the value beta in terms of lambda. So beta is equal to, from equation 1, 4 lambda minus alpha, that is equal to 4 lambda minus alpha is 2 lambda plus root 3, and 4 lambda minus 2 lambda is 2 lambda minus root 3. So we got alpha in terms of lambda, beta in terms of lambda, and take the equation 2, alpha beta is equal to 5, and substitute alpha beta, then you will get the value of lambda. Right, that's the plan. Therefore, go to the equation 2, where you have alpha beta is equal to 5, alpha is 2 lambda plus root 3, beta is 2 lambda minus root 3, multiply is equal to 5. This is 4 lambda square minus 3 is equal to 5. This will imply 4 lambda square is equal to 8. This will imply lambda square is equal to 2. Therefore, lambda is equal to plus or minus root 2. But lambda, in equation 1 you can see lambda is given to be in the hypothesis, in the hypothesis it is given to be lambda greater than 0. Therefore, minus root 2 is discarded and we get lambda is equal to root 2. Right, we got lambda is equal to root 2. Go to equation 6 and substitute the value of lambda and square it. So From 6, alpha plus 2 beta plus gamma is equal to 4 lambda plus 3 root 2. But lambda value is root 2. So 4 root 2 plus 3 root 2. And that will be 7 root 2. Square it. Alpha plus 2 beta plus gamma whole square is equal to 7 root 2 whole square. That is 7 sevens are 49 into 2. That is 98. That's your answer. So the answer to this question is 98, and that is the detailed discussion of the solution of the problem, which is based on the properties of the roots of quadratic equations. And the question is from the section complex numbers and quadratic equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section sequences and series, and this question is related to the sum of the given series. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let S is equal to 2 plus 6 by 7 plus 12 by 7 square plus 20 by 7 cube plus 30 by 7 to the power of 4 plus so on and so forth. Then 4 times S is equal to, we are given 4 options. Option A, 7 by 3 whole square. Option B, 7 cube by 3 square. Option C, 7 by 3 whole cube. Option D, 7 square by 3 cube. We are given an infinite series. This is the infinite series, and S is its sum, and required to find 4 times S. That is the given question to us. So let's now discuss the solution of the problem in detail. We have S is equal to the series 2 plus 6 by 7 plus 12 by 7 square plus 20 by 7 cube plus 30 by 7 to the power of 4 plus so on and so forth. Right. Now multiply throughout by 1 by 7. Then the left hand becomes S by 7. Write it under S. And the terms are written like this. So 2 after multiplication it becomes 2 by 7. Write it under 6 by 7. 6 by 7 after multiplication it is 6 by 7 square. Write it under 12 by 7 square plus so on and so forth plus 12 by 7 cube plus 20 by 7 to the power of 4 plus 30 by 7 to the power of 5 plus so on and so forth as discussed. Right. Now subtract. So it will be 1 minus 1 by 7 yes. So subtracting 1 minus 1 by 7 S is equal to 2 plus 6 by 7 minus 2 by 7 4 by 7 plus 12 by 7 square minus 6 by 7 square, that is 6 by 7 square, plus doing this way 8 by 7 cube plus 10 by 7 to the power of 4. Agreed. This will imply 1 minus 1 by 7 is 6 by 7 S is equal to 2 plus 4 by 7 plus 6 by 7 square plus 8 by 7 cube plus 10 by 7 to the power of 4 plus so on and so forth. Now look at the, and 2 is to be thought of as 2 by 1, and look at the numerators 2, 4, 6, 8, 10. It is in arithmetic progression with first term 2 and common difference 2, and 2 by 1. This is 1, 1 by 7, 1 by 7 square, 1 by 7 cube, 1 by 7 to the power of 4. It is in geometric progression. So that is why this series is called the series of arithmetico-geometric progression. It is a series of arithmetico-geometric progression. Agreed. Now multiply once again each term by 1 by 7 and do as we have done earlier. So 6 by 7 square s is equal to 2 by 7 under 4 by 7, 4 by 7 square under 6 by 7 square, 6 by 7 cube right under 8 by 7 cube, plus so on and so forth. We have. Now subtracting, we will get 6 by 7 minus 6 by 7 square in brackets into s is equal to 2 plus 4 by 7 minus 2 by 7, 2 by 7 plus 6 by 7 square minus 4 by 7 square, 2 by 7 square plus so on and so forth, 2 by 7 cube plus 2 by 7 to the power of 4 plus so on and so forth. This is the right hand side is a geometric series with the first term a is equal to 2 and r, the common ratio, is 1 by 7. Agreed. And it is an infinite series where the common ratio is 1 by 7 is less than 1. Therefore, the sum of this infinite geometric series is a by 1 minus r, that is 2 by 1 minus 1 by 7. So 6 by 7 minus 6 by 7 square, when you simplify, you will get 36 by 7 square into s is equal to, this is the sum of the infinite geometric series, and it is a by 1 minus r. A is 2, r is 1 by 7. It is 2 by 1 minus 1 by 7. That is 2 by 6 by 7. That we have written as 2 by 6 multiplied by 7. 2 by 6 is 1 by 3. This is 7 by 3. 7 by 3. What is that we want? We want 4s. We want 4s. So 36 by 7 square, yes, in that 4s, keep it here, and the remaining things send it there. That means this 1 by 7 square will go multiply as 7 square, and 9 into 4, that 9 will come down. So that means 7 square into 7, 7 cube by 3 into 9. So that will be 4s is equal to 7 cube by 3 into 9 is 27. That is 7 by 3 whole cube. So 4s is 7 by 3 whole cube. Let's look at our options. And our answer 7 by 3 whole cube appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem, which is related to the sum of the given series from the section sequences and series. Again, is a question. This type of questions have already appeared in the previous examinations, and I am sure it's a very easy question to you, and no doubt this question is a very straightforward and simple question. So that is the detailed discussion of the solution of the problem. I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is based on the concepts of mean and variance. This question is from the section Statistics and Probability. The given question is the mean and variance of the data 4, 5, 6, 6, 7, 8, x, y, where x less than y are 6 and 9 by 4 respectively. Then x to the power of 4 plus y square is equal to, we are given 4 options. Option A 162, option B 320, option C 674, option D 420. We are given the data 4, 5, 6, 6, 7, 8, x, y, and we are given the mean and the variance of this data is respectively 6 and 94, 6 and 9 by 4. The mean and variance of this data is given to be 6 and 9 by 4, and the relation between x and y is given as x less than y. Required to find the value of x to the power of 4 plus y square. That is the given question to us. Let's now discuss the solution of the problem in detail. We have 8 observations. So we say n is equal to 8 observations, and the data is 4, 5, 6, 6, 7, 8, x, y, where x less than y. And it is given mean is equal to x bar is equal to 6. Let's recall the definition of the mean. If x1, x2, xn are n observations, then the mean is given by x bar is equal to the sum of the observations by the number of observations, that is equal to x1 plus x2 plus xn by n. So in our case, the mean is equal to 4 plus 5 plus 6 plus 6 plus 7 plus 8 plus x plus y by the number of observations, that is 8, is equal to the mean 6. Cross multiply, and the sum of these numbers is 36 plus x plus y. Cross multiply, 8 6 are 48, and then it will give you x plus y is equal to 12. X plus y is equal to 12, and we are given the variance as 9 by 4. The variance is denoted by sigma square, and the variance definition sigma square is equal to sigma I is equal to 1 to n xi square, sums of the squares of the data, by the number of observations minus x bar square, that is the mean square. So in our case, the variance is given by 4 square plus 5 square plus 6 square plus 6 square plus 7 square plus 8 square plus x square plus y square by the number of observations 8 minus the mean square, that is 6 square, is equal to 9 by 4 given. Agreed. Now simplify. 4 square is 16 plus 25 plus 36 plus 36 plus 49 plus 64 plus x square plus y square, and take the LCM throughout. Minus 8 into 36 is equal to 9 by 4 into 8. Simplify, you'll get 226 plus x square plus y square minus 8 into 36, 288, is equal to 9 by 4 into 8, that is equal to 18. Simplify further, x square plus y square minus 62 is equal to 18. Agreed? This will imply x square plus y square is equal to 18. Thus, what is that we want? We want the value of x power 4 plus y square. Now we have x less than y. X plus y is equal to 12 from the first equation. Second equation, x square plus y square is equal to 18. Now you can very easily guess what is x and y. But anyway, I'll show you some workout in the snippet. So we have x plus y is equal to 12, x square plus y square is equal to 80, x less than y. X plus y is equal to 12 will imply x plus y whole square is equal to 12 square, squaring on both sides. This will give rise to x square plus y square plus 2xy is equal to 144, but x square plus y square is 80 plus 2xy is equal to 144. So 2xy is equal to 64. So therefore xy is equal to 32. Now x plus y is equal to 12, xy is equal to 32. Now it's very easy to guess. So x is 4 and y is 8. Sum is 12, product is 32. Correct. And x is equal to 4, y is equal to 8. x is equal to 8, y is equal to 4 also is a possibility, but we are given x less than y. Therefore, x is equal to 4, y is equal to 8. So, the values of x and y we have. So, we compute x to the power of 4 plus y square value. So, x is equal to 4, y is equal to 8. Therefore, x power 4 plus y square is equal to, x is 4 power 4 plus y square 8 square, that is equal to 256 plus 64, that is equal to 320. So, the value of x to the power of 4 plus y square is 320. Let's look at our options. Our answer 320 appears against option B. Therefore, the answer for this question is option B. So that is the detailed discussion of the solution of the problem on the concepts of mean and variance from the section Statistics and Probability. And I am sure that you have understood the solution of this problem. And I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. This given problem is on the probability as a proportion of areas, and the question is from the section Statistics and Probability. The given question is, if a point A with coordinates x, y lies in the region bounded by the y-axis, straight lines 2y plus x is equal to 6 and 5x minus 6y is equal to 30. Then the probability that y less than 1 is, we are given 4 options. Option A 1 by 6, option B 5 by 6, option C 2 by 3, option D 6 by 7. So we have y-axis and 2 straight lines, 2y plus x is equal to 6 and 5x minus 6y is equal to 30. And the point A with coordinates x, y lies in the region bounded by this y-axis and 2 straight lines. Then we have to find the probability that the point A of x, y when y less than 1 is. So we have to find the probability that a point A of x, y when y less than 1 is the one required to find. Now, before entering into the discussion of the problem, let us note down the probability as a proportion of geometric areas. It is done like this. If a point A with coordinates x, y is equally likely to be anywhere in a given region R, that means the point A with coordinates x, y is any point in the given region R with area A suffix R, then the probability P of the point A with coordinates x, y is in a particular subregion R prime of R. The probability P of the point, this point A, x, y is in a particular subregion R prime of R with area A suffix R prime, and then the probability P is given by P is equal to A suffix the area of the subregion R prime by the area of the region R. So that's the probability. Now let's get into the question and solve the right. That's the given question to us. We now discuss the solution of the problem in detail. We have two straight lines. Call them as L1 and L2, where L1 is 2y plus x is equal to 6 and L2 is 5x minus 6y is equal to 30 and y-axis. So this is x-axis, y-axis and the origin O. Now L1 and L2 intersect y-axis at a point say P with coordinates 0, 3, the point say Q with coordinates 0, minus 5 respectively. Now let's see, let's get into the L1, right? And y-axis, so L1 and L2 intersect the y-axis. So y-axis means put x is equal to 0 in this. Then you will get 2y is equal to 6, y is equal to 3. That means at a point P 0, 3. In L2, put x is equal to 0. Then you will get minus 6y is equal to 30. That is y is equal to minus 5. That means L2 cuts the y-axis at a point say Q with coordinates 0, minus 5. Let's get into L1. Yes, L1 is here. L1. It intersects the y-axis at 0, 3 and L2 intersects the y-axis at 0, minus 5. Further, L1 and L2 intersect at a point say R. Take these L1 and L2, solve, and I have not shown the how to solve and all that. You are very familiar how to solve two equations in two unknowns. Do it. And the point of intersection of L1 and L2 is 6, 0. And let's call that as the point R. L1 and L2 intersect at R 6, 0. That means on the x-axis. Agreed. Let R be the region bounded by the y-axis L2 and L1. So the shaded region R is shown here. The light yellow color we have shaded. That is the region R. That is, R is the triangle PQR. Agreed. Given the point A with coordinates x, y is any point in the region R, therefore we compute the area of the region R, A suffix R. And how do we get the area? That is the area of the triangle PQR. For the triangle PQR, take PQ as the base and the height is OR. So half into PQ into OR. So half into PQ into OR. Now how much is PQ? This is 3 units. This is 3 units. These are 5 units. 5 plus 3, 8. So PQ is 8 units multiplied by, and OR is, origin is 0, 0, R is 6, 0. So the OR will be the x coordinate of R minus the x coordinates of 0. That is 6 minus 0 is 6. So 1 by 2 into 8 into 6. 8 6 are 48 by 2, that is equal to 24. So the area of the region R, we got it. Agreed. let's get into the next slide. So that is the figure so far. That's what we have done here. Now, the line y is equal to 1 intersects L1. Now, get into L1, put y is equal to 1. So then you will get 2 plus x is equal to 6. That is x is equal to 4. That means y is equal to 1 intersects the line L1 at a point S with coordinates 4, 1. And y is equal to 1 intersects y-axis obviously at 0, 1. Let's call this as t. So here is the line S. Y is equal to 1. It intersects L1 at S with coordinates 4, 1. Intersects y-axis at t, that is 0, 1. Now why are we considering y is equal to 1? We have to talk about all those points A with coordinates x, y of the region R when y less than 1 we have to consider. Then we talk about the probability of such points. Required to find the probability P of the point A with coordinates x, y less than 1 of the region R. Of the region R. So it is of the region R means it is a sub-region. So that is all those points in a particular sub-region R prime of R. R prime is a part of R, where R prime is bounded by y-axis, L2, L1 and y is equal to 1. It is y-axis bounded by y-axis, L2, L1 and y is equal to 1. So note that R prime is the quadrilateral Q, R, S, T, and this is the shaded portion. This is the shaded portion. QRST is this one in light pink color. Agreed. Now we want to find the area of R prime. A suffix R prime, that is equal to area of the subregion R prime, that is equal to area of the quadrilateral QRST. And we will find the area of the quadrilateral QRST as the area of the triangle PQR minus the area of this small triangle which is in yellow, light yellow. That is PTS. So the area of the triangle PQR minus the area of the triangle PTS. So the area of triangle PQR minus area of triangle PTS. The area of triangle PQR we have already calculated, that is AR, that is 24 minus 1 by 2 into, it's a triangle 1 by 2 into base. Base is TS. Base is TS multiplied by the height is PT. And 24 minus 1 by 2 into base TS is the x coordinate of S minus the x coordinate of T, that is 4 minus 0 is 4. And PT is the y coordinate of P minus the y coordinate of T, that is 3 minus 1, 2. So 1 by 2 into 4 into 2, and that 2 cancels. 24 minus 4 is 20. Now the required probability P is equal to AR prime by AR. The area of R prime by the area of R, that is 20 by 24, that is equal to 5 by 6. Let's look at the options here. And our answer 5 by 6 appears against option B. Therefore, the answer to this question is option B. And that is the detailed discussion of the solution of a problem which is based on the computing of probability as a proportion of areas from the section probability, statistics and probability. and it is definitely an interesting question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given problem is related to the solution of a given linear differential equation. And this question is from the section Differential Equations. The given question is, if the solution curve of the differential equation in brackets tan inverse y minus x into dy is equal to in brackets 1 plus y square into dx passes through the point 1, 0, then the abscissa of the point on the curve whose ordinate is tan 1 is. We are given four options. Option A 2e, option B 2 by e, option C 2, option D 1 by e. We are given a differential equation, that is tan inverse y minus x in brackets dy is equal to 1 plus y square in brackets dx. And given the solution curve of this differential equation passes through the point 1, 0. Then required to find the abscissa, means the x coordinate of the point on the curve whose ordinate, that is whose y is tan y. That means find x when y is equal to tan 1. So that is the question. That's the given question to us. Let's now discuss the solution of the problem in detail. This is our given differential equation. This can be written as 1 plus y square into dx by dy is equal to tan inverse y minus x. Now bring this minus x from right hand side to left hand side. It becomes plus x and divide throughout by 1 plus y square. Then this becomes dx by dy plus 1 by 1 plus y square into x is equal to tan inverse y by 1 plus y square. So this differential equation is of the form dx by dy plus p of y, p a function of y into x is equal to q a function of y. What is it? It is a first order linear differential equation in x. To solve such a differential equation, we find its integrating factor. IF stands for integrating factor, and it is given by e power integral p of y dy. Now in our case, p of y is 1 by 1 plus y square, q of y is tan inverse y by 1 plus y square. Now after finding the integrating factor, we write down its general solution, and it is given by x into the integrating factor is equal to integral of q of y, that is the right hand side function, multiplied by the integrating factor, integrate with respect to y, plus c, where c is an arbitrary constant. Now in our case, the integrating factor is e power integral p of y dy. P of y is 1 by 1 plus y squared. So this is e power integral 1 by 1 plus y squared dy. And this integral is tan inverse y. So this will be e power tan inverse y. Now the general solution we will write down. Now x into integrating factor e power tan inverse y is equal to integral of q of y. Q of y is tan inverse y by 1 plus y square into the integrating factor, that is e power tan inverse y. Then integrate with respect to y plus c, where c is a constant of integration, which is an arbitrary constant to be evaluated. Right. Now, how do we integrate this? That we will show you in this snippet. So, for this, put tan inverse y is equal to t, differentiating, you will get 1 by 1 plus y squared dy is equal to dt. So, put tan inverse y is equal to t, differentiating both sides. 1 by 1 plus y squared dy is equal to dt. Then the integral now becomes 1 by 1 plus y squared dy will be dt, and tan inverse y is t into e power t. So the integral t e power t dt. Now this is a standard integral whose integral is known to us. It's a known integral. Right. So we do it by the integration by parts, and we get t minus 1 in brackets into e power t, and replace t by tan inverse y. Then we will get tan inverse y minus 1 in brackets multiplied by e power tan inverse y. That is the integral of that. Let's go back to our mainstream. This is equal to, after the integration, it will be tan inverse y minus 1 into e power tan inverse y plus c. Thus we get the general solution as x into e power tan inverse y is equal to tan inverse y minus 1 in brackets into e power tan inverse y plus c. We continue in the next slide. We have the GS, right? Now what is this one? It's a relationship between x and y, and it gives rise to a curve. As c is an arbitrary constant, it will give rise to a family of curves. But each relation is a solution of the differential equation. So you get a family of the solution curves of the given differential equation when c is an arbitrary constant. From this family, find out that curve, that solution curve, which passes through 1, 0. That means if you put x is equal to 1, y is equal to 0, then c will be evaluated, and that for that value of c, this will give rise to the solution curve of the differential equation. So given the solution curve passes through 1, 0, so you put x is equal to 1, y is equal to 0 in the above general solution, we get x is 1 into e power tan inverse 0. Wherever there is y, you write it 0. In brackets, tan inverse 0 minus 1 into e power tan inverse 0 plus c. Now, tan inverse 0 is 0. E power 0 is 1. Tan inverse 0 is 0 minus 1 into e power tan inverse 0 is 1 plus c. So, that is 1 is equal to 0 minus 1 plus c. So, c will be equal to 2. So, substituting the value of c in the GS, then you will get the solution curve of the differential equation, what the question is talking about. So, this is the solution curve. Now, what is to be found? So, you find the abscissa, means x coordinate of the point on the curve whose ordinate is tan 1, that is whose y is tan 1. That means find x when y is equal to tan 1. So required to find x when y is equal to tan 1. So that means to put y is equal to tan 1 in the above particular solution and solve for x, then you will get the abscissa, what is required in the question. So x into, wherever there is y, you write tan 1, e power tan inverse of y means tan 1 is equal to tan inverse of y means tan 1 minus 1 into e power tan inverse of tan 1 plus 2. So tan inverse of tan 1 is 1. So e power 1 will be e, x into e is equal to, this is 1 minus 1, 0. 1 minus 1 is 0. So plus 2. That means you will get x into e is equal to 2. Therefore, the abscissa, the x coordinate, when y is tan 1 is given by x is equal to 2 by e. That is your answer. Let's look at our options. Our answer 2 by e appears against option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of a problem which is related to the solution of a given linear differential equation from the section differential equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section Sets, Relations and Functions. This given question is related to the concepts of invertible functions. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let S be a set consisting of the elements 1, 2, 3, 4, 5 up to 10. Define a function f from S to S as f of n is equal to 2n when n is equal to 1, 2, 3, 4, 5. F of n is equal to 2n minus 11 when n is equal to 6, 7, 8, 9, 10. Let g be a function from S to S such that f compose g of n is equal to n plus 1 if n is odd and is equal to n minus 1 if n is even. Then g of 10 multiplied by, in brackets, g of 1 plus g of 2 plus g of 3 plus g of 4 plus g of 5 is equal to, we are given a set S consisting of the elements 1, 2 up to 10. We are given a function from S to S defined like this. And we are also given a function g S to S. It is given such that f compose g of n is this one. Then required to find the value of g of 10 multiplied by, in brackets, g of 1 plus g of 2 plus g of 3 plus g of 4 plus g of 5. Let's now discuss the solution of the problem in detail. We have the set S consisting of the elements 1, 2, 3 up to 10. F is a function from S to S defined by f of n is equal to 2n if n is equal to 1, 2, 3, 4, 5. F of n is equal to 2n minus 11 if n is equal to 6, 7, 8, 9, 10. We are also given g, a function from S to S such that f compose g of n is equal to n plus 1 if n is odd. F compose g of n is equal to n minus 1 if when n is even. Required to find the value of g of 10 multiplied by, in brackets, g of 1 plus g of 2 plus g of 3 plus g of 4 plus g of 5. And to obtain this value, to obtain the above value, we need the action of G on S. That means the action of G on the elements of S. If we know, then we can do that. Now we are given f composed G of n is f of G of n is defined as n plus 1 when n is odd is equal to n minus 1 when n is even. Now, if in case f is invertible, that means if f inverse exists, then G of n will be f inverse of n plus 1, f inverse of n minus 1 on the respective values of n. So, if f inverse exists, that is if f is invertible, then G of n is equal to f inverse of n plus 1 when n is odd. G of n is equal to f inverse of n minus 1 when n is even. So, to find this value, G of 10 multiplied by G of 1 plus G of 2 etc. up to G of 5 plus G of 5. So, G of n is known when f inverse is known. Therefore, our first question is f invertible? If f is invertible, what is the action of f inverse on the elements of S? We have S. F is a mapping from S to S defined like this. So, if f of n is equal to 2n when n is equal to 1, 2, 3, 4, 5. When n is 1, f of 1 is 2, f of 2 is 4, f of 3 is 6, f of 4 is 8, f of 5 is 10. So, f maps 1, 2, 3, 4, 5 onto 2, 4, 6, 8, 10 respectively. Now, what this f will do? In the next case, 2n minus 11, when n is equal to 6, 2, 6 are 12 minus 11, 1, 7 2s are 14 minus 11, 3. So, f maps 6, 7, 8, 9, 10 onto 1, 3, 5, 7, 9. Agreed. So, we see that f is 1 to 1 and on to. How? F is mapping distinct elements of the domain onto the distinct elements of the range. The range is also S. Therefore, f is 1, 1. When f is 1, 1, f is a mapping from S to S. Both S and S are finite sets. F is 1 to 1, then it will be automatically on 2. So, since f is 1 to 1 and f is a mapping from S to S where order of S is finite, then f is on 2. So, f is 1, 1 and on 2. That means f is bijective. When f is bijective, f inverse exists. When f is bijective, f is invertible and f inverse exists. So, now from the action of the map f inverse can be guessed. So, f inverse. Now, from the action of f, it is clear f inverse maps 2, 4, 6, 8, 10 onto 1, 2, 3, 4, 5 respectively. And f inverse maps 1, 3, 5, 7, 9 onto 6, 7, 8, 9, 10 respectively. So, from this, the action of f inverse is known on individual terms. But we want to know a formula for that. So, from the first one, f inverse of 2 is 1, f inverse of 4 is 2, etc. f inverse of 10 is 5. We'll tell you f inverse of n is n by 2, where n belongs to 2, 4, 6, 8, 10. Similarly, for the next one. What is that? For the second one, we'll show you. And we are very familiar with the method of finding the inverse of a bijective function. And we have f of n action and how f is mapping. We know, we have seen this one. Now f is invertible. Therefore, y is equal to f of x implies and implied by x is equal to f inverse of y. Yes, when f is invertible. Now take the first case. First case means 1, 2, 3, 4, 5 onto 2, 4, 6, 8, 10. So the first case is y is equal to f of x is equal to 2x, f of x is equal to 2x, when x belongs to the set 1, 2, 3, 4, 5. So when x belongs to the set consisting of 1, 2, 3, 4, 5, y will be 2x, means y will belong to 2, 4, 6, 8, 10. Y belongs to. So y is equal to 2x, then x will be y by 2. So what is x? X is f inverse y. So this will be f inverse y is equal to y by 2 for all y belongs to 2, 4, 6, 8, 10. So what's the action of f inverse? F inverse of n is n by 2. N belongs to 2, 4, 6, 8, 10. Okay, we got it. The next one. So y is equal to f of x is equal to 2x minus 11 when x belongs to the set consisting of 6, 7, 8, 9, 10. So note that x belongs to 6, 7, 8, 9, 10, then 2x minus 11, that is y belongs to 1, 3, 5, 7, 9. So this we have already seen. So y is equal to 2x minus 11. Solving for x, we will get y plus 11 by 2. So what is x? X is f inverse y. So this will imply f inverse y is equal to y plus 11 by 2, where y belongs to 1, 3, 5, 7, 9, the set. So the action of f inverse is f inverse of n is equal to n plus 11 by 2, where n belongs to 1, 3, 5, 7, 9. So now f inverse is completely known for us. F inverse of n is equal to n by 2 when n belongs to the set consisting of 2, 4, 6, 8, 10. And f inverse of n is equal to n plus 11 by 2 when n belongs to the set consisting of 1, 3, 5, 7, 9. So f inverse is known. So we will get g of n. Yeah, that we will do in the next slide. We have f inverse of n, and g of n we have seen in the first slide. G of n, f compose g of n is equal to n plus 1 when n is odd, is equal to n minus 1 when n is even. When f is invertible, then g of n will be f inverse of this, respectively. This we have seen. So now, when n is odd, n plus 1 is even. When n plus 1 is even, what is f inverse? This is n plus 1 by 2. When n is even, n minus 1 is odd. When n is odd, n plus 11 by 2. So that means n minus 1 plus 11 by 2. The above one, n plus 1 by 2. So that will be equal to n plus 1 by 2 if n is odd, n minus 1 plus 11 by 2 if n is even. So n minus 1 plus 11 is n plus 10 by 2. So g of n, action of g of n is known now, n plus 1 by 2 if n is odd. G of n is equal to n plus 10 by 2 if n is even. So what is that we want? We want g of 10 multiplied by, in brackets, g of 1 plus g of 2 plus g of 3 plus g of 4 plus g of 5. So g of n is completely known. So g of 1 is odd, 1 plus 1 by 2, that is 1. G of 2 is even, 2 plus 10 by 2, that is 6. G of 3 is odd, 3 plus 1 by 2, that is 2. G of 4 is even, 4 plus 10 by 2, that is 7. G of 5 is odd, 5 plus 1 by 2, that is 3. And g of 10, so 10 is even, 10 plus 10 by 2, 20 by 2, that is 10. So all these elements are known now. So this will be equal to g of 10, that is 10, multiplied by g of 1 plus 6 plus 2 plus 7 plus 3. and in brackets when you add it is 19. 10 times of 19, that is 119. That is your answer, and that is the detailed discussion of the solution of a problem which is related to the invertible functions, and it is from the section sets, relations and functions. And to elaborate each and every step we have taken more time, but otherwise it is very easy. Okay, I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is based on the applications of the derivatives, and this question has come from the section Differential Calculus. The given question is, if y of x is equal to x power x, where x greater than 0, then d square x by dy square plus 20 at x is equal to 1 is. So now we are given y as a function of x, and it is given as x power x to the power of x, where x is positive. Required to find the value of d square x by dy square plus 20 at x is equal to 1. This is our given question. Let's now discuss the solution of the problem in detail. We have y, a function of x, given as x power of x, that is equal to x power x square, where x is positive. Right. What is that we want? We want d square x by dy square, but we have y of x, which is a function of x given. So we normally find its first derivative and second derivative, that is d square y by dx square. So, but we want d square x by dy square. So, what is the relationship between second derivative of y with respect to x with the second derivative of x with respect to y? So, if y is equal to y of x is any differentiable function, then we have a relationship between the second derivative of y with respect to x and the second derivative of x with respect to y. What is that? D square y by dx square is equal to minus dy by dx whole cube into d square x by dy square. So, from this you can find d square x by dy square, provided if you know d square y by dx square and dy by dx. So now it's now easy. Now we want this first derivative. To differentiate this one, we take logarithms on both sides. Taking logarithms on both sides, ln of y of x is equal to x square ln of x. Now differentiate with respect to x, we get derivative of ln of yx is 1 by yx. Yx with respect to x is y prime x. That is the first derivative, that is dy by dx, is equal to, we use the product rule for differentiation, first function x square into the derivative of the second function, the derivative of ln x is 1 by x, plus second function ln x into the derivative of the first function, that is the derivative of x square is 2x. So we got this one, cancel this one, x greater than 0, no problems will come. So x square by x is x, and send this yx which is sitting in the denominator on the left hand side to the right hand side. Then you will get y prime x is equal to y of x multiplied by, in brackets, x plus 2x multiplied by ln of x. And differentiate once again, we want d square y by dx square. So differentiate with respect to x on both sides. Y double prime x is equal to the derivative of the first multiplied by the second function plus first function into the derivative of the second. We have done it. We have done it here. So now in this x cancels, we'll get 1. So you will get this is equal to y prime x into x plus 2x into ln x plus y of x into 1 plus 2 times 1 plus ln of x. We can still further simplify. This 1 plus 2 is 3, 3 plus ln x you can write in the bracket. So everything is same. In the last bracket we have written y of x into multiplied by 3 plus ln of x. Agreed. So we got a dy by dx and a d square y by dx square. We continue in the next slide. So we have y of x, its first derivative and the second derivative, what we have done in the last slide. Agreed. We have that relation, that is d square y by dx square is equal to minus dy by dx whole cube into d square x by dy square. D square y by dx square is y double prime x is equal to minus y prime x whole cube into d square x by dy square. Put x is equal to 1. So you'll get put x is equal to 1, y double prime at 1 is equal to minus y prime at 1 whole cube into d square x by dy square to be evaluated at x is equal to 1. Now what are these values? What are the, and y double prime we know, y prime we know, y we know. So now go back to y prime x in this, put x is equal to 1. So we'll get y prime 1 is equal to y of 1 into x is 1 plus ln of 1 is 0. But what is y of 1? So we go back, y of 1 is equal to 1 power 1, that is 1. So come here, y of 1 is 1, 1 into 1 is 1. So y prime 1 is 1. Agreed. And go to the y double prime x. So y double prime, in that x is equal to 1 you substitute, y prime 1 multiplied by 1 plus ln of 1 is 0 plus y of 1 into 1 plus 2 into 1, that is 3. This is already we have done is 3. 3 plus 1, 4. So we got 4 is the y double prime 1 is 4. So substitute here, y double prime 1 is 4 is equal to minus y prime 1 is 1, 1 cube is 1 only, minus d square x by dy square at x is equal to 1. Thus we got d square x by dy square at x is equal to 1 is equal to minus 4. What is that we want? Required to find the value of d square x by dy square plus 20 when x is equal to 1. That is d square x by dy square at x is equal to 1 plus 20 is equal to minus 4 plus 20, that is equal to 16. Thus d square x by dy square plus 20 at x is equal to 1 is equal to 16. That's your answer. That is the detailed discussion of the solution of the problem from the subsection applications of derivatives from the differential calculus. Now, the key to the success of proving this or solving this question is this concept. That is the relationship between d square y by dx square and d square x by dy square when y is a differentiable function of x. If you know this, then the problem is easy. So if you do not know, please learn this derivation, or else you remember this relationship. So that is the detailed discussion, and I am sure that you have understood the solution of the problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is to find an equation for which sine 36 degrees is a root. This question is from the section Trigonometry. The given question is alpha is equal to sine of 36 degrees is a root of which of the following equations? We are given four options. Option A, 16 x to the power of 4 minus 10 x square minus 5 is equal to 0. Option B, 16 x to the power of 4 plus 20 x square minus 5 is equal to 0. Option C, 16 x to the power of 4 minus 20 x square plus 5 is equal to 0. Option D, 16 x to the power of 4 minus 10 x square plus 5 is equal to 0. The question is self-evident. That is the given question to us. Let us now discuss the solution of the problem in detail. We recall the value of sine of 36 degrees. And we have alpha is equal to sine of 36 degrees is equal to under the square root of 10 minus 2 root 5 whole by 4. Agreed. Now, squaring on both sides, we get alpha square is equal to 10 minus 2 root 5 in the numerator by 4 square, that is 16. Cross multiply. 16 alpha square is equal to 10 minus 2 root 5. That will imply 16 alpha square minus 10 is equal to minus 2 root 5. We observe that 2 is a common factor throughout. Cancelling 2 throughout, we get 8 alpha square minus 5 is equal to minus root 5. So squaring on both sides, we get 8 alpha square minus 5 whole square is equal to minus root 5 whole square. 8 alpha square whole square is 64 alpha to the power of 4 minus 2 into 8 alpha square into 5, that is minus 80 alpha square plus 5 square, that is 25, is equal to 5. Now bringing that 5 from right hand side to the left hand side, we get 64 alpha to the power of 4 minus 80 alpha square plus 20 is equal to 0. We observe that 4 is a common factor throughout. Therefore, cancelling 4 in this equation, we'll get 16 alpha to the power of 4 minus 20 alpha square plus 5 is equal to 0. Therefore, alpha is equal to sine 36 degrees is a root of the equation 16x to the power of 4 minus 20x square plus 5 is equal to 0. Let us look at our options. Our answer 16x to the power of 4 minus 20x square plus 5 is equal to 0 appears against option C. Therefore, the answer to this question is option C. We can also do this question by considering cos 36 degrees the value of cos 36 degrees. Why? Because remembering cos 36 degrees value is easy. Many people remember this. Alternate method. Recall cos 36 degrees is equal to root 5 plus 1 by 4. It is very simple. Many people remember this value. That is cos 36 degrees. Agreed. And we want sine 36 degrees. So we will write squaring. Sine square 36 degrees is equal to 1 minus cos square 36 degrees. Square it and then use sine square 36 degrees is equal to 1 minus cos square 36 degrees. So sine square 36 degrees is alpha square is equal to 1 minus cos 36 is root 5 plus 1 whole by 4 whole square. Now taking the LCM throughout, that will be equal to 16 alpha square is equal to 16 minus root 5 plus 1 whole square is 5 plus 2 root 5 plus 1. 5 plus 1 6. 16 minus 6 is 10. So that is equal to 10 minus 2 root 5. That is equal to 16 alpha square, and proceed from here. So that is the detailed discussion of the solution of the problem from the section Trigonometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is on the expansion of a given binomial, and it is from the section Binomial Theorem and its applications. The given question is, if the sum of the coefficients of all positive powers of x in the binomial expansion of in brackets x power n plus 2 by x power 5 whole power 7 is 939, then the sum of all possible integral values of n is. We are given the binomial expansion of in brackets x power n plus 2 by x power 5 whole power 7, and it is given the sum of the coefficients of all positive powers of x in this expansion is 939. Then required to find the sum of all possible integral values of such n is. That is the given question to us. We now discuss the solution of the problem in detail. We have in brackets x power n plus 2 by x to the power of 5 whole power 7. Right, it is in the binomial expansion. It is sigma r is equal to 0 to 7 into 7 CR, right, and x power n whole power 7 minus r multiplied by 2 by x power 5 to the power of r. Remember the binomial expansion. Agreed. Now still further simplify. This is sigma r is equal to 0 to 7 CR into x to the power of 7n minus 7r, 7n minus nr, x power 7n minus nr, and 1 by x to the power of 5 multiplied, that is x to the power of minus 5r. Then it will be x to the power of 7n minus nr minus 5r, and 2 power r will come here. So in this power take n common, that will be x power 7 minus r in brackets multiplied by n minus 5r. So it will be sigma r is equal to 0 to 7 cr 2 power r into x power in brackets 7 minus r into n minus 5r. Agreed. Now let's expand this still further. R is equal to 0. If you put r is equal to 0, 7c0 2 power 0 into x power 7n, because r is 0. Now put r is equal to 1. 7c1 2 power 1 x power 7 minus 1 6n minus 5 times 1 5. So 7c1 2 power 1 x power 6n minus 5. Put r is equal to 2. 7c2 2 square into x to the power of 7 minus 2, that is 5n minus 5 times 2 10, plus r is equal to 3. 7c3 2 cube x to the power of 4n minus 15. R is equal to 4 plus 7c4 2 power 4 x power 3n minus 20. R is 5. 7c5 2 power 5 x to the power of 2n minus 25 plus etc. plus etc. So we have missed two terms, that of r is equal to 6, r is equal to 7. Two more terms are there. Agreed. Now what is given to us? The sum of the coefficients of all the positive powers of x in this expansion is 939. So x to the power of 7, the coefficient is 760 into 2 power 0 means 1 only. 7 c0 is 1. And the next coefficient is 7c1 2 power 1. The next coefficient is 7c2 2 square. Next coefficient is 7c3 2 cube. Let's add up to this. Let us see whether we are going to get 939 or is it spilling over by 939 or is falling short by 939. Let us see. So now sum of the coefficients of x to the power of 7 minus r multiplied by n minus 5r for r is equal to 0, 1, 2, 3. That means the first 4 terms. So this will be 7c0 into 2 power 0, 7c1 into 2 power 1, 7c2 into 2 square, 7c3 into 2 cube. Up to this we have come. So now 7c0 1, 7c1 1, 7c1 is 7 multiplied by 2, 7c2 is 21 multiplied by 4, 7c3 is 35 multiplied by 8. Now multiply and add 1 plus 14 plus 84 plus 280. This is 379. It is falling short for this 939. So 939. So let's add one more term. That means r is equal to 0, 1, 2, 3. Now add one more, that is 4. So now, so sum of the coefficients of x to the power of 7 minus r multiplied by n minus 5r for r is equal to 0, 1, 2, 3, 4. Up to 3, we have 379. So 379 plus 7c4 into 2 power 4. So this is 7c4 is 7c3, that is 35 into 2 power 4 is 16. So 379 plus 35 into 16, that is 379 plus 560, that is 939. Yes, we have come up to that. So that means these powers must be positive, because it is given the sum of the coefficients of the positive powers of x in this expansion is 939. So these powers are positive, and the remaining are negative. That's the conclusion. We continue in the next slide. That's what we have so far. Therefore, this power is 7 minus r multiplied by n minus 5r is positive for r is equal to 0, 1, 2, 3, 4. Why? Because the sum of the coefficients of all the positive powers of x is 939. And what are the powers left? What are the power? 3 more powers left, up to 4, 5, 6, 7. 7 minus r into n minus 5r must be negative for r is equal to 5, 6, 7. So thus 7 minus r into n minus 5r is greater than 0. For r is equal to 4, automatically the before ones will be positive. And 7 minus r into n minus 5r is a negative for r is equal to 5. Once it becomes negative, the next powers, these powers, for the next r values, these powers will be negative. Agreed. So what is our concern? We have to find those positive integral values of n for which these two inequalities holds good. Take all such positive integral powers, then add. So to find all possible integral values of n, anyway, these are integral values of n, they will be automatic, they are positive, for which these two inequalities holds good. So for r is equal to 4, this is 3n minus 20, because r is 4 greater than 0. For r is equal to 5, 2n minus 5 times 5, 25 is less than 0. So that means this is n greater than 20 by 3. This means n less than 25 by 2. So that means we got the inequality 20 by 3 less than n less than 25 by 2. 20 by 3 is 6.36 or 18, 6.6. 6.6 less than n less than 12.5. What are the positive integers n that lie between 6.6 and 12.5? So this will be n is equal to 7, 8, 9, 10, 11, 12. So we got now. So we have to find the sum of these things. So the sum of all possible integral values of n is sum of all these 7 plus 8 plus 9 plus 10 plus 11 plus 12, that is 57. That's our answer. That is our required answer. Agreed. That is the detailed discussion of the solution of a problem from the section binomial theorem. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is on the counting the number of matrices in a given context in the question. This problem is from the section Permutations and Combinations. The given question is, let capital A be a square matrix of order 2 cross 2 whose entries are from the set consisting of 0, 1, 2, 3, 4, 5. If the sum of all the entries of the matrix A is a prime number P where 2 less than P less than 8, then the number of such matrices is, we have capital A square matrix of order 2 whose entries are from the set consisting of 0, 1, 2, 3, 4, 5. Now, if the sum of all the entries of this matrix A is a prime number which lies properly in between 2 and 8, then the number of such matrices is we now discuss the solution of the problem in detail. Throughout this discussion, capital T denotes the set consisting of the elements 0, 1, 2, 3, 4, 5. Given P is a prime number, 2 less than, P less than 8. So, which are the prime numbers which lie between 2 and 8 but not 2 and 8? They are 3 or 5 or 7. So, 2 less than P less than 8 implies P belongs to the set consisting of 3, 5, 7. Let capital S be the set of all 2 by 2 matrices capital A whose entries are A, B, C, D. The entries coming from T, that is the set consisting of 0, 1, 2, 3, 4, 5, and the sum of the entries is equal to P, where P is either 3 or 5 or 7. So, this is equal to P union Q union R, where P is the set of all 2 by 2 matrices whose entries are coming from the set capital T, such that the sum of the entries is equal to 3. The sum of the entries is equal to P, P is equal to 3. So, the Q will denote a similar case where the sum of the entries is 5. QR denotes the set of all such matrices where the sum of the entries is 7. Right. So, what is to be found? Required to find order of S. We have S is equal to P union Q union R. Note down, if you take P and Q, they are disjoint, because in this case the sum of the entries is 3. In the case of Q, the sum of entries is 5. Obviously, no element of P is an element of Q, no element of P is an element of R, no element of Q is an element of R. Therefore, P, Q, R are pairwise disjoint. Therefore, order of S is equal to order of P plus order of Q plus order of R, because P, Q, R are pairwise disjoint. So, now the problem reduced to find the order of P, order of Q and order of R. We will do this in the next slide. Case 1 we consider, let us take capital P, the set of all 2 by 2 matrices whose entries are A, B, C, D. They are coming from the set T such that the sum of the entries is 3. Agreed. How many such matrices are there? That's the question, order of P. So now let us recall a result, what we have studied. The number of non-negative integral solutions of the equation x1 plus x2 plus xr is equal to n is n plus r minus 1 c r minus 1. So this will count the number of non-negative integral solutions of this equation. Now in our case, A, B, C, D, the solutions are coming from 0, 1, 2, 3, 4, 5. That means they are non-negative integers. So it is an equation where n is 3 and number of variables are 4, and we want to find the integral non-negative integral solutions of this one. And for each set of non-integral solutions of A, B, C, D, we will get a matrix P. Therefore, the number of the matrix of P is given by this formula. So, in this case, n is 3, r is 4. So, order of P is equal to 3 plus 4 minus 1, C 4 minus 1. This is equal to 6C3, and when simplified, we will get 20. Now, case 2. We have Q, set of all 2 by 2 matrices whose entries are A, B, C, D. They are coming from the set T such that the sum of the entries is equal to 5. Again, the order of Q is equal to the number of non-negative integral solutions of the equation A plus B plus C plus D is equal to 5. So n will take the value 5, r will take the value 4. So then order of Q is equal to 5 plus 4 minus 1, n plus r minus 1, c r minus 1, that is 4 minus 1. That is equal to 8C3. Now when simplified, we will get 56. The order of Q is 56. Now case 3, we have capital R is the set of all 2 by 2 matrices whose entries are A, B, C, D. They are coming from T, and the sum of the entries is equal to 7. Naturally, we cannot use this formula, the above formula, that is n plus r minus 1 by cr minus 1. The reason is T is 0, 1, 2, 3, 4, 5 only. So we cannot. So that means to get this 7, maybe something like 0, 0, 1, 6 will give you 7, but the 6 doesn't belong to T. And 0, 0, 0, 7 will give you 7, but the 7 doesn't belong to T. So if we use this formula, all such matrices are also included. But we want those matrices whose entries are coming from 0, 1, 2, 3, 4, 5 only. So this formula doesn't work. So to obtain the order of R, we consider a set R star. That we will do in the next slide. Suppose we consider R star is equal to the set of all capital A 2 by 2 matrix whose entries are A, B, C, D. A, B, C, D belongs to T star. This time it is T star, it's not T, where T star is 0, 1, 2, 3, 4, 5 and 6 and 7. 6 and 7. So 7 entries are there in this. It is T star. Now, and the sum of the entries is 7. Now your formula works. So according to the formula, n is 7, r is 4. So order of r star is equal to 7 plus 4 minus 1, C4 minus 1, that is equal to 10, C3, that is equal to 120. But remember that r star has more elements than r, because this 6 and 7 are also taking place. So the order of r is less than order of r star. So how do we go for finding the order of r? So for that, let us consider the set X consisting of all those 2 by 2 matrices B whose entries are A, B, C, D. This matrix belongs to R star, where one of these ABCD is 6 and the rest belongs to T. T is 0, 1, 2, 3, 4, 5. Such that A plus B plus C plus D is equal to 7. So one of them is 6 and the rest are coming from 0, 1, 2, 3, 4, 5. Such matrices you consider, they will be in R star. So now that is, this we will write it as x1 union x2 union x3 union x4. That means the 4 sets we have written, where the set x1 is the set of all those 2 by 2 matrices B whose one element is a 6. The remaining are B, C, D belongs to this R star. Why this belongs to R star? Because one of the entry is 6. So 6 means this will be in R star, but this matrix will not be in R, will not be R, such that BCD belongs to T. They takes the values 0, 1, 2, 3, 4, 5 only, such that 6 plus B plus C plus D is equal to 7. We will once again see this. B is the set of all those matrices whose entries are 6B first row, second row CD belongs to R star, BCD belongs to the set consisting of 0, 1, 2, 3, 4, 5, and the sum of the entries is B plus C plus D is equal to 1, because 6 we have taken, 7 minus 6 is 1, B plus C plus. Okay, now we want to find the non-negative integral solutions for BCD such that B plus C plus D is equal to 1. We apply that formula n plus r minus 1, C r minus 1. In this case, n is 1, r is 3. So order of x1 is equal to n plus r minus 1, 1 plus 3 minus 1, C r minus 1, 3 minus 1. That will be 3C2, that is 3. So that means 6 sitting in the 1, 1 position, and the sum of the entries is 7. That will reduce to this second equation, and this will give you the answer. So what is x2? x2 is 6 sitting in the 1, 2 position. x2 is equal to B, the set of all A6 CD belongs to R star. This matrix belongs to R star because 6 is there in it, and ACD belongs to T. T is 0, 1, 2, 3, 4, 5. A plus C plus D is equal to 1. It is as above only. 6 sitting in the different position. Order of x2 is 3. And x3, where 6 is sitting in the 2, 1 position, then order of x3 is 3. Then in x4, 6 is sitting in A2 position, and the order of x4 is 3. Now, what is order of x now? Now, order of x is equal to x1 union x2 union x3 union x4. They are pairwise disjoint because 6 is sitting in different positions. Therefore, order of x is equal to order of x1 plus order of x2 plus order of x3 plus order of x4, because they are pairwise disjoint, and each is of order 3. Therefore, 4 into 3, that is equal to 12. Agreed. We consider another set, capital Y, that is equal to the set of all those matrices, 2 by 2 matrices. B is equal to A, B, C, D belongs to R star. One of them is 7 and the rest are 0. Then the sum of the entries automatically will be 7. Then what is the order of y? That we do in the next slide. Agreed. R star we have. Order of R star is 120. X we have, where 6 is one of the entries. And order of X is equal to 12. We now consider let B is equal to the set of all those matrices. A, B, C, D belongs to R star. One of A, B, C, D is 7. And the rest belong to T, such that A plus B plus C plus D is equal to 7. And one of them is 7. The sum of the entries is 7, means the remaining 3 elements must be 0. It is the set of all 2 by 2 matrices A, B, C, D belongs to R star. One of A, B, C, D is 7, and each of the rest is 0. Now, we can very easily see who are they. Who are they? That means 1, 7, and the remaining are all 0. How many are there? So these are 7. The 2 by 2 matrix 7, 0, 0, 0, 0, 0, 7, 0, 0, 0, 0, 7, 0, 0, 0, 0, 7. How many? 4. So order of y is equal to 4. We don't need any formula for this. We can very easily list out. So order of y is equal to 4. Agreed. Now, each element or each matrix of y belongs to R star, but it doesn't belong to R. Why? Because 7 is present in that. Right. We have R is the set of all 2 by 2 matrices whose entries are A, B, C, D, belongs to T, where T is 0, 1, 2, 3, 4, 5, and the sum of the entries is 7. Now, note that R to the set R union X means 6 participates, union Y 7 participates. Then who are these matrices? These matrices are precisely the matrix of R star, where 6 and 7 participates. And now the order of R union X union Y is equal to order of R star, and this order of R union X union Y is order of R plus order of X plus order of Y. That is equal to order of R star. Why this is plus is coming? Because R, X, Y are pairwise disjoint. Agreed. Agreed. So order of X is 12, order of Y is 4. So if you substitute here, order of R will be 120 minus 16. That is equal to 104. Thus we got order of R. Now what is that we want? We want the order of S. What is S? S is the set of all those 2 by 2 matrices whose entries are coming from T, that is 0, 1, 2, 3, 4, 5. And the sum of the entries is either 3 or 5 or 7. That's equal to P union Q union R. And order of S is equal to order of P plus order of Q plus order of R, because they are pairwise disjoint. This we have seen in the first slide itself. And the order of P is 20, order of Q is equal to 56. This we have seen in the second slide. Agreed? So now, what is to be found? Order of S. So now order of S is equal to order of P plus order of Q plus order of R. Order of P is 20, order of Q is 56, order of R is 104. Adding, we'll get 180. That is your answer. So the order of S is equal to 180 is the required answer to this question. Agreed. And that is the detailed discussion of the solution of the problem on the counting the number of matrices in a given context in the question, and it is from the section permutations and combinations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section Complex Numbers and Quadratic Equations. And this question is related to a circle and an ellipse. This question has appeared in the Joint Entrance Examination Main held on 27th June 2022 in the second shift. The given question is the number of points of intersection of mod of z minus in brackets 4 plus 3i is equal to 2 and mod z plus mod z minus 4 is equal to 6, where z belongs to the set of all complex numbers is. We are given 4 options. Option A 0, option B 1, option C 2, option D 3. So we are given modulus of z minus 4 plus 3i is equal to 2 and mod z plus mod of z minus 4 is equal to 6, where z belongs to the complex plane, and required to find the number of points of intersection of these two curves. We now discuss the solution of the problem in detail. We are given modulus of z minus in brackets 4 plus 3i is equal to 2. Recall, modulus of z minus z1 is equal to r, where r is greater than 0, represents a circle with the center at z1 and a radius r. The radius r. Now this represents a circle with the center at 4 plus 3i in the complex plane and the radius 2. It is a circle with the center at 4 plus 3i and a radius 2. We are also given this curve, given mod z plus mod of z minus 4 is equal to 6. Let's call this as the equation 1. And what is this curve? What is the locus of z in the complex plane? Let us recall the equation mod of z minus z1 plus mod of z minus z2 is equal to k. This describes an ellipse with the foci at z1 and z2 if k is greater than the distance between z1 and z2, that is mod of z1 minus z2. If it is so, then what is this given curve 1? Now, here k is equal to 6, z1 is equal to 0, z2 is equal to 4. You notice that 6 is greater than mod of z1 0 minus z2 minus 4. That is 6 greater than 4. Yeah, it is correct. So, it represents an ellipse E with foci at 0, complex number 0, that means the origin 0, 0, and at a point A 4, 0. So these are the foci of this ellipse. Agreed. Now notice now, the center of the circle is 4 plus 3i, and one of the foci is at capital A 4, 0. So that means x is equal to 4, that is the straight line, parallel to y-axis or the imaginary axis, will pass through the center of the circle and the foci, one of the foci of the ellipse, capital A. Note that the line x is equal to 4 passes through the center 4 plus 3i of the circle and the focus A with coordinates 4, 0 of the ellipse E. So, how this ellipse will look like? I am not deriving that equation, that is the Cartesian equation, I am not deriving. Therefore, that it's an ellipse, I will agree. So, we take this one. So, we have the circle with center 4 plus 3i. X is equal to 4 passes through the center of the circle and also passes through one of the foci of the ellipse, that is capital A with coordinates 4, 0. Agreed. So, where is this and how is this ellipse? I am not showing or I am not drawing and I do not know. Let us say. Now, what is this complex number? That means what are the coordinates of this point? The center is 4 plus 3i. The radius is 2 units. So, walk backwards on the line x is equal to 4, 2 units. Then it will be x plus 5y. And walk backwards 2 units on x is equal to 4. You will get 4 plus I. And the above one is 4 plus 5y. Agreed. So, that means since the center of the circle is 4 plus 3i and its radius is 2, the points 4 plus I and 4 plus 5i lie on the circle. In fact, they are the end points of the one of the diameters, that is on the x is equal to 4. Agrees. Our question is, where is 4 plus I with respect to this ellipse E? Our question is, where is this point 4 plus I with respect to this ellipse? Now, take this 4 plus I, z is equal to, and substitute in mod z plus mod z minus 4 minus 6. Now, when you substitute this, after substitution, if it is equal to 0, this point will lie on the ellipse. If it is greater than 0, this point lie outside this ellipse. And if it is less than 0, then z is equal to 4 plus I lie strictly inside the ellipse E. So, now substitute mod z, mod of 4 plus I plus mod of z minus 4, mod of 4 plus I minus 4 minus 6. Mod of 4 plus I is under the square root of 4 square plus 1 square, that is root 17. 4 cancels here. Mod I is plus 1 minus 6. Square root of 17 is little more than 4, that is, let us say 4.1, something like that. It cannot be 5. It cannot be 5. So, 4 point something plus 1, it will be 5 point something minus 6, it will be negative. It will be negative. It is negative means what? 4 plus I, the point lies strictly less than 0, strictly inside E. So that means a point 4 plus I of the circle lies strictly inside the ellipse E. So imagine now what happens. This implies the circle intersects the ellipse E in 2 points because a point of the circle lies strictly inside the ellipse. That means the circle will pass through that point and that point is strictly inside that one. When it is passing, it crosses the ellipse once, and when it is leaving, it crosses again the circle. Again the circle again intersects the ellipse. So the first, to reach this 4 plus I, the circle crosses the ellipse once. After passing through 4 plus I, it crosses once again the ellipse in another point. So that in total it intersects, that is the circle intersects the ellipse E in 2 points. So that's our answer. Let's look at our options. Our answer 2 appears again next to option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of a problem which is related to a circle and an ellipse in the complex plane from the section complex numbers and quadratic equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is related to the solution of an initial value problem. This question is from the section Differential Equations. The given question is, let y is equal to y of x be the solution of the differential equation 1 minus x square dy is equal to, in brackets, xy plus x cube plus 2 multiplied by under the square root of 1 minus x square, bracket close, dx, where minus 1 less than x less than 1 and y at 0 is equal to 0. If the integral minus 1 by 2 to plus 1 by 2 of under the square root of 1 minus x square into y of x dx is equal to k, then k inverse is equal to. So we are given y is equal to y of x is the solution of this differential equation with this initial condition. And if y of x is the solution, that solution you take and put that solution in this integral. Integral minus 1 by 2 to plus 1 by 2 under the square root of 1 minus x square into that solution y of x dx. And if that is equal to k, required to find the value of k inverse. That's our given question. We now discuss the solution of the problem in detail. We have the given initial value problem. What is an initial value problem? A differential equation equipped with an initial condition is called an initial value problem. Here we have, this is the differential equation and y of 0 is equal to 0 is the initial condition. Agreed. Now this differential equation can be written as 1 minus x square into dy by dx is equal to xy plus x cube plus 2 multiplied by under the square root of 1 minus x square. This will imply dividing throughout by 1 minus x square, we will get dy by dx minus this xy is brought to the left hand side minus x by 1 minus x square multiplied by y is equal to x cube plus 2 by 1 minus x square into under the square root of 1 minus x square. After cancellation, root of 1 minus x square will sit down in the denominator. Agreed. That is the differential equation. Agreed. And how this is looking like? This is of the form dy by dx plus p of x, a function of x into y, is equal to q of x. So what is this? It is a well-known first order linear differential equation. It is an linear ordinary differential equation in y. Right. To solve such a differential equation, we take its integrating factor. The integrating factor is given by e power integral p of x dx. Then we write down its general solution, and it is given by y into integrating factor is equal to integral of q of x into integrating factor, integrate with respect to x, plus c, where c is an arbitrary constant. It's a constant of integration. Agreed. So let's get into our question. In our question, p of x is minus x by 1 minus x square. Q of x is x cube plus 2 by under the square root of 1 minus x square. Now the integrating factor is e power integral px dx is equal to e power integral minus x by 1 minus x square dx. So we will integrate this one. To integrate this one, put 1 minus x square is equal to t. Differentiate minus 2x dx is equal to dt, and minus x dx is dt by 2. Right. So get into the integral minus x by 1 minus x square dx is equal to minus x dx is dt by 2. This dt by 2. And 1 by 1 minus x square is 1 by t. So this is 1 by 2 into integral of 1 by t, that is ln t. That is ln t. So that is the integral, and the t you put back 1 minus x square, and 1 by 2 you take care. That is ln of root t, and the root of t is 1 minus x square. So ln of root of 1 minus x square is the integral of minus x by 1 minus x square dx. Now come back to our mainstream. So put it here. So this is e power integral ln of root of 1 minus x square, and that will be equal to under the square root of 1 minus x square. Agreed. Agreed. So we got the integrating factor, and how the general solution is given by y into integrating factor is equal to integral of the right hand side function q of x into integrating factor with respect to x plus c. So the general solution is given by y into integrating factor under the square root of 1 minus x square is equal to integral of q of x. Q of x is the x cube plus 2 by under the square root of 1 minus x square into integrating factor under the square root of 1 minus x square dx plus c. We continue in the next slide. The general solution is this one, and the square root of 1 by 1 minus x square, which is appearing in the denominator as well as in the numerator, cancel. Then you will get the integral of x cube plus 2 dx plus c. Integral of x cube is x to the power of 4 by 4. Integral of 2 dx is 2x plus c. So it is x to the power of 4 by 4. Yeah, integral of x cube is x to the power of 4 by 4. Integral of 2 with respect to x is 2x plus c. So therefore the GS is given by y into under the square root of 1 minus x square is equal to x to the power of 4 by 4 plus 2x plus c. To evaluate c, we are given the initial condition. So given y at 0 is equal to 0. That means y is 0 when x is 0. So put y is equal to 0 and put y is equal to 0 and x is equal to 0. This is not y is 0. This is x is equal to 0. put y is equal to 0 and x is equal to 0 in the above, then we'll get c is equal to 0. Agreed. Then the particular solution is given by y is a function of x, y of x multiplied by under the square root of 1 minus x square is equal to x to the power of 4 by 4 plus 2x. C is 0. We have evaluated. This is the particular solution. Why this is called a particular solution? It is a solution obtained for a particular choice of x and y. X and y. So for x and y, there is a y at 0. That is, the value of y is equal to 0 when x is equal to 0. Then c is 0. Thus we get a particular solution. Agreed. Agreed. Now what is that we want to find? We are given k value. So we are given k is equal to integral minus 1 by 2 to plus 1 by 2 square root of 1 minus x square into y of x dx. And look the above. The above one is root of 1 minus x square into yx is x to the power of 4 by 4 plus 2x. So in the place of this one, you write x to the power of 4 by 4 plus 2x. That is equal to integral minus 1 by 2 to plus 1 by 2 x to the power of 4 by 4 plus 2x dx. Separate the integral. Integral of the sum is equal to sum of their integrals. So 1 by 4 integral minus 1 by 2 to plus 1 by 2 x to the power of 4 dx plus 2 times integral x dx with the appropriate limits. Now look at here. Look at here. X to the power of 4 is an even function. It is minus a to plus a. It's an even function. And this will be 2 times 0 to 1 by 2 x to the power of 4 dx. And look at x. X is an odd function. X is an odd function. This will be equal to minus 1 by 2 to plus 1 by 2. An odd function with respect to x is 0. So that is the rule what we have studied in our integration classes. Agreed. Now this will be equal to 1 by 4 2 times integral 0 to 1 by 2 x power 4 dx. So because it is an even function, because it is an odd function, it is 0. So 1 by 4 into 2 is 1 by 2 into integral of x to the power of 4 with respect to x is x to the power of 5 by 5, and it is a definite integral to be evaluated between the limits x is equal to 0 to 1 by 2. So this will be equal to 1 by 2 into 5. Yes, this 5 will be 1 by 2 into 5. X to the power of 5 when x is equal to 1 by 2, 1 by 2 to the power of 5. When x is equal to 0, it is 0. So 1 by 2 to the power of 4, 5 is 1 by 32 into 1 by 10. That is equal to 1 by 320. That is the value of k, but we want k inverse, and that is equal to 320. That is the required answer to this question. So that is the detailed discussion of the solution of a given initial value problem, and the question is from the differential equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is related to the system of equations with complex coefficients, and the problem is from the section Determinants. The given question is, let for some real numbers alpha and beta, a is equal to alpha minus I beta, if the system of equations 4ix plus in brackets 1 plus iy is equal to 0 and 8 multiplied by cos 2 pi by 3 plus I sin 2 pi by 3 x plus a bar y is equal to 0 has more than one solution, then alpha by beta is equal to. We are given 4 options. Option A, minus 2 plus root 3. Option B, 2 minus root 3. Option C, 2 plus root 3. Option D, minus 2 minus root 3. Now, we are given a system of two equations in two unknowns x and y with complex coefficients. What are those equations? 4ix plus 1 plus I y is equal to 0, 8 times cos 2 pi by 3 plus I sin 2 pi by 3 x plus a bar y is equal to 0. And A is given to be a complex number alpha minus I beta, where alpha beta are real numbers. Given that this system has more than one solution, then required to find the value of alpha by beta. That is the given question to us. We now discuss the solution of the problem in detail. We have A is equal to alpha minus I beta belongs to the set of complex numbers. Given the system of two homogeneous linear equations. Why these are homogeneous? See, an equation is equal to 0. That means the right hand side is 0 in both the cases. So, is a system of two homogeneous equations. These are two equations, homogeneous and linear equations in two variables x and y with complex coefficients. What are the coefficients? Coefficients are 4i, 1 plus I, which are complex numbers. So, these equations are first one and the second one, 8e to the power of 2 pi I by 3. E to the power of 2 pi I by 3 is cos 2 pi by 3 plus I sin 2 pi by 3 into x plus a bar y. So we have a system of two homogeneous because it is equal to 0, homogeneous linear equations in two variables with complex coefficients. Let's write down its matrix equation. Capital A into capital X is equal to 0, matrix 0, where A is the 2 by 2 matrix, which is the coefficient matrix, which is formed by the coefficients of the equations. The coefficient matrix is 4i, 1 plus I, 8e to the power of 2 pi by 3 I, a bar. X is the column vector consisting of the unknowns, and 0, look at the 0, is a bold, is a column vector consisting of 0, 0. Agreed. Now, let us recall this result for the infinitely many solutions for a homogeneous system of linear equations. The system, homogeneous linear system, has more than one solution. If it has more than, it will admit always one solution, that is trivial solution. It admits more than one solution means is a non-trivial solution. If there is one non-trivial solution, then it has infinitely many solutions. So, the system has more than one solution if this is the result what we have. Determinant of A is equal to 0. Agreed. Now, determinant of A is equal to determinant of the coefficient matrix is equal to 0. So, this is here. Determinant of the coefficient matrix is equal to 0. So, take this determinant, expand and get the values of alpha and beta from this. So A bar is involved. A bar is involved means A is alpha plus I, alpha minus I beta. A bar is alpha plus I beta. From this, solve for alpha and beta and then find out alpha by beta. That's our goal. So we have A is a complex number, alpha minus I beta, required to find alpha by beta. The given system has more than one solution, implies determinant of A is equal to 0. That is determinant of 4i 1 plus I, first row, 8 e to the power of 2 pi by 3 I, A bar is equal to 0. So this is a 2 by 2 determinant A, B, C, D, first row A, B, second row C, D. So the determinant is A, D minus B, C. So 4I A bar minus 8 e to the power of 2 pi by 3 I into 1 plus I. Agreed. Cancel 4 throughout. A is alpha minus I beta. A bar will be alpha plus I beta. And e to the power of 2 pi I by 3 is cos 2 pi by 3 plus I sin 2 pi by 3. All these things you write down. First, cancel. So, 4I, A bar is alpha plus I beta. E to the power 8, e to the power of 2 pi by 3, we have written into 1 plus I. Cancel throughout by 4. Cancel throughout by 4. Then 4 will go. We will have a minus 2 here. So I into alpha plus I beta minus 2 into, this is cos 2 pi by 3 plus I sin 2 pi by 3 is none other than the omega, one of the cube roots of unity, that is well known, minus 1 plus I root 3 by 2, 2 to cancel and take this minus inside. So multiply now I alpha minus beta. This will imply I alpha minus beta, 2 to cancel. Take this 1 minus inside, that will be 1 minus I root 3 into 1 plus I. Now multiply. These are two complex numbers. We know how to multiply the complex numbers. Agreed. I alpha minus beta plus, when you multiply, the real part is 1 plus root 3 plus I times the imaginary part is multiply 1 minus root 3. Agreed. So write down as a complex number A plus IB. So this will imply minus beta plus 1 plus root 3. That is the real part, plus I times alpha plus 1 minus root 3. That is the imaginary part. And on the right hand side 0. 0 is none other than the 0 complex number. The 0 complex number is 0 plus I0. So the equating the real and imaginary parts, we get minus beta plus 1 plus root 3 is equal to 0. Alpha plus 1 minus root 3 is equal to 0. This is the imaginary part, this is the real part. So from this, alpha you will get root 3 minus 1 and beta is equal to root 3 plus 1. Now required to find alpha by beta. Alpha is root 3 minus 1 by root 3 plus 1. Now rationalize the denominator. For that, multiply and divide by the conjugate of root 3 plus 1, that is root 3 minus 1 by root 3 minus 1. In the denominator, root 3 plus 1 into root 3 minus 1 is 3 minus 1, that is 2. In the numerator, root 3 minus 1 whole square, that will be 3 plus 1 minus 2 root 3, that is 4 minus 2 root 3 by 2. And when you cancel 2, both in the numerator and denominator, you will get a 2 minus root 3. So alpha by beta is 2 minus root 3. That is our answer. Let's look at our options. Our answer, alpha by beta is equal to 2 minus root 3, appears against option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of a problem that is related to the system of homogeneous linear equations with complex coefficients from the section determinants. I am sure that you have understood the solution of this problem and I wish you all the best. Thank you. we now discuss the solution of a problem from the section Differential Calculus, and the problem is on the value of the derivative of a given function. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let f be a differentiable function in the open interval 0 to pi by 2. If the integral cos x to 1 t square f of t dt is equal to sin cube x plus cos x, then 1 by root 3 f prime of 1 by root 3 is equal to. We are given 4 options. Option A, 6 minus 9 root 2. Option B, 6 minus 9 by root 2. Option C, 9 by 2 minus 6 root 2. Option D, 9 by root 2 minus 6. We are given a differentiable function in the open interval 0 to pi by 2, and integral cos x to 1 t square f of t dt is equal to sin cube x plus cos x. So from this we have to get that from this we have to get the answer of 1 by root 3 of f prime of 1 by root 3 from the given 4 options. That is the given question to us. Let us now discuss the solution of the problem in detail. We are given f, a differentiable function in the open interval 0 to pi by 2, and the integral cos x to 1 of t square f of t with respect to t is equal to sin cube x plus cos x. Agreed. Now differentiate with respect to x, and while differentiating the differential under the integral sign from the given limits, for that we use Newton-Leibniz formula for this on the left hand side. Let's look at the Newton-Leibniz formula, and the derivative is obtained as upper function 1 into t is equal to 1, you have to substitute 1 square f of t, and the derivative of 1 is 0. So 0 minus, for the lower function, cos square x, f of cos of x with respect to x, that is minus sin x. Agree? So that will be 0 minus cos square x, f of cos x with respect to x is minus sin x, is equal to the derivative of sin cube x, 3 sin square x cos x, minus the derivative of cos x is minus sin x. So we have used Newton-Leibniz formula. Agreed. Now minus into minus plus, and divide throughout by cos square x sin x. Then you will get f of cos x. F of cos x is equal to 3 sin square x cos x by cos square x sin x. That will be 3 tan x minus sin x by cos square x sin x is 1 by cos square x, that is minus secant square x. Agreed. Now differentiate both sides with respect to x. So f of cos x is equal to cos x derivative. First differentiate with respect to cos x, f prime cos x with respect to x minus sin x, into the derivative 3 is equal to 3 times derivative of tan x secant square x minus the derivative of secant square x is 2 times secant x. The derivative of secant x with respect to x is secant x tan x then you will have minus 2 secant square x tan x. Agreed. Now divide throughout by minus sin x, because we want f prime of 1 by root 3. So we are trying to get to f prime of cos x now. Divide throughout by minus sin x. Then you will get f prime cos x is equal to 3 secant square x by minus sin x plus 2 secant cube x minus 2 secant square x tan x by minus sin x is plus 2 secant cube x. Now we want f prime of 1 by root 3. So put cos x is equal to 1 by root 3. And it's a very simple case. How to get sin x? You draw a diagram and then find the opposite side by hypotenuse and all that. Sin x is equal to root 2 by root 3. Right. We go and substitute. F prime of 1 by root 3 is equal to minus 3 into secant square x is root 3 whole square, that is 3, by sin x is root 2 by root 3 plus 2 into secant cube x is root 3 whole cube. That's equal to 9 root 3 by root 2 plus 2 into 3 root 3, that is 6 root 3. So we want 1 by root 3 f prime of 1 by root 3. So multiply by 1 by root 3. 1 by root 3 of f prime of 1 by root 3 is equal to 6 root 3 by root 3 is 6 minus 9 root 3 by root 2 by root 3, that is 9 by root 2. So that is the answer to this question. Let's look at our options. Our answer appears against option B. The answer to this question is option B. So that is the detailed discussion of the solution of the problem to find the value of the derivative of a given function. And before we conclude the video, I want to make a remark. So we make a remark here. That's our given question. And you take the given integral. So we have the integral cos x to 1 t square f t dt is equal to sin cube x plus cos x. Let's call this as the equation 1. Now this is not a balanced equation. In fact, this statement is not true. So we want to modify this one appropriately so that it will be meaningful. Now what we do is the interval is 0 to pi by 2. Let x tends to 0 from the right. So limit, note that limit x tends to 0 plus, that means x is tending to 0 from right, of the left hand side of this equation 1. That is 1 integral cos x to 1 t square f t dt. And if we take the limit will be from 1 to 1 only, integral 1 to 1 only, and thereby the answer is 0. Agreed. Take the right hand side. Limit x tends to 0 plus of sin cube x plus cos x is 0 plus 1, 1. So note now, as the limit x tends to 0 plus, the left hand side is 0, the right hand side is 1. They are not balanced, they are not equal, and thereby this statement is not true. Right. So the given statement is not true. We want to modify that one so that the question 1 after modification is meaningful and it is a true statement. And what all we do is to get this answer, 1, what do we do? To get the, so what do we do? So the left hand side is 0, the right hand side is 1. To get the 0 only, the answer, from the right hand side subtract 1. So integral cos x to 1 t square f t dt is equal to sin cube x plus cos x minus 1. Now, as limit extends to 0 plus, this is also 0 and this is also 0, and thereby it will be meaningful, and it is, in fact, it is a true statement. It is a true statement. But sir, how is that we got the answer and we have proceeded? Yeah, this minus 1 doesn't take part when we differentiate both sides with respect to x. So we started with this, differentiate with respect to x, we said. So even if there is some constant, that will go off, and from there onwards everything is true. Everything is true. So, however, the next steps, as in the solution what we have seen in the earlier slide, will follow, because we started taking the differentiation on both sides. Therefore, this minus 1, even if it is there in the function, after differentiation, it will vanish and they will be equal. And thereby, we will be getting the answer also. However, there is no threat to the answer that we have arrived. So, this little modification is necessary, and perhaps the examiner might have forgotten, to put a minus 1 here, something like that. Something happened. So, that's what I wanted to say. So, this little modification we want to do. So, that's all for now. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section Differential Calculus. The problem is related to the left-hand limit of the given function. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let bracket t denote the greatest integer less than or equal to t, and curly bracket t denote the fractional part of t. The integral value of alpha, for which left hand limit of the function f of x is equal to bracket 1 plus x plus, it is a quotient where the numerator is alpha power in the power 2 bracket x plus curly bracket x plus bracket x minus 1 by the denominator 2 times bracket x plus curly bracket x at x is equal to 0 is equal to alpha minus 4 by 3 is. And we are now given a function. This is your function involving bracket x and the curly bracket x. Agreed. And we want to find the integral value of this alpha, what is appearing in this function, for which the left hand limit of this function at x is equal to 0 is given to be alpha minus 4 by 3. Then we have to find the integral value of alpha. Agree? So let's now get into the question. That's your given question. We first get familiarized with the greatest integer function and curly bracket function, right? So these are the two concepts which we require. let x be any real number, then bracket x be the greatest integer less than or equal to x, and the curly bracket x be the fractional part of x, then curly bracket x is equal to x minus bracket x. That means from the given real number, subtracting the greatest integer less than or equal to x, then you will get fractional part. And bracket x plus n, where n is any integer, then it will be bracket x plus n. Agreed. So these are the two results which you should know to get into the solution. We now discuss the solution in detail. Bracket of 1 plus x is equal to 1 plus bracket x. We are using bracket of x plus n is equal to bracket x plus n for any integer n. Agreed. Agreed. Then 2 times bracket x plus curly bracket x, we write it as bracket x plus curly bracket x in red, and bracket x plus curly bracket x is x, because curly bracket x is equal to x minus bracket x. So bracket x plus curly bracket x will be the given real number x, then it will be equal to bracket x plus x. Agreed. Now let's get into the function. So this is your function. For the first one, bracket of 1 plus x, you can write 1 plus bracket x, and 2 times bracket x plus curly bracket x, you have to write bracket x plus x, both in the power in the numerator. Agreed. So that will be equal to 1 plus bracket x for this, plus alpha in the power 2 times bracket x plus curly bracket x is written as bracket x plus x, and plus bracket x minus 1 as it is in the numerator, bracket x in the denominator, bracket x plus x. Agreed. So now let's get into what will the limit, the left hand limit at x is equal to 0 for bracket x. Why we are doing? Because we have to get the left hand limit of this function at x is equal to 0. For that reason, these are the the functions which are inside the function f of x. So we have to find limit x tends to 0 minus, that is the left hand derivative of bracket x is equal to limit h tends to 0, because x is tending to 0 from the left, it is 0 minus h we have written, and as h tends to 0. For x we have written 0 minus h, yes, as h tends to 0. It will be 0 minus h, where h is positive, which is very close to 0, then 0 minus h will be less than 0 but greater than minus 1. Then in that case, the greatest integer not exceeding 0 minus h is minus 1. And limit x tends to 0 minus of bracket x plus x is equal to limit of the sum is equal to sum of their limits, we have written. Limit x tends to 0 minus of bracket x we have already seen above, minus 1. And limit x tends to 0 minus of x is 0. Why? Because it is same as limit x tends to 0 of x, because x is a continuous function. So it will be 0. And minus 1 plus 0 is minus 1. Agreed. Now we are ready to compute limit x tends to 0 minus of f of x is equal to limit x tends to 0 minus of the function. The function is, we have seen here. Now limit of the sum is equal to sum of their limits. Yes, we have written, and it is equal to 1 plus limit x tends to 0 minus of bracket x is minus 1. So it is 1 minus 1. Limit extends to 0 minus of the quotient is equal to quotient of their limits, and that will be equal to alpha to the power of limit extends to 0 minus of bracket x plus x is minus 1 plus 0 minus 1 we have written, and bracket x is minus 1 by bracket x plus x in the denominator minus 1 plus 0. Now 1 minus 1 cancels, and this will be equal to alpha to the power of minus 1 minus 2 by minus 1. That is 2 minus 2 by minus 1, 2 minus alpha inverse, that is 1 by alpha. But this is given to be equal to alpha minus 4 by 3. So this is equal to alpha minus 4 by 3. We continue for further simplification of this one in the next slide. This is what we have. Take the LCM here, take the LCM on the right hand side, we have taken, and cross multiply. We have cross multiplied and simplify. We will get a quadratic in alpha, that is 3 alpha square minus 10 alpha plus 3 is equal to 0. Factorization is very easy. We factorize, we get alpha minus 3 into 3 alpha minus 1 is equal to 0. Then we get the values of alpha. Alpha is equal to 3 or 1 by 3. What is that we want? We want the integral value of alpha. In this 3 and 1 by 3, the integral value of alpha is 3. Therefore, alpha is equal to 3. That's your answer. And that is the detailed discussion of the solution of the problem related to the left-hand limit of a given function which involves bracket x function and curly bracket x function. Right. And it is this question strongly depends upon the properties of bracket x. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section Integral Calculus. The problem is related to a definite integral involving greatest integer function. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is the integral 0 to 1 by, in the denominator, 7 to the power of bracket 1 by x dx, where bracket denotes the greatest integer function is equal to. So we have to evaluate this definite integral 0 to 1 by 7 to the power of bracket 1 by x with respect to x, where bracket is the greatest integer function. We are given 4 options. Option A, 1 plus 6 log 6 by 7 to the base e. Option B, 1 minus 6 log 6 by 7 to the base e. Option C, log 7 by 6 to the base e. Option D, 1 minus 7 times log 6 by 7 to the base e. That is the given question to us. Let's now discuss the solution of the problem in detail. We put 1 by x is equal to t. Differentiating, we'll get minus 1 by x square dx is equal to dt. Then dx is equal to minus x square dt, but x is 1 by t, so it will be equal to dx is equal to minus 1 by t square dt. Agreed. Now take the integral. Now because this is a definite integral, what happens to the limits? Now when x is equal to 0 will imply t tends to infinity. 1 by 0 tends to infinity. When x is equal to 1, t is 1. Then the given definite integral 0 to 1 by 7 to the power of bracket 1 by x dx is equal to, the transformed integral is integral 0 to 1 means infinity to 1. Dx we have written minus 1 by t square dt, minus 1 by t square dt into 1 by 7 to the power of bracket t, because bracket 1 by x is t, bracket t. And now this minus is taken care of. We have changed the limits. Infinity to 1 we have written as 1 to infinity, that minus will go off. Integral 1 to infinity 1 by t square 1 by 7 to the power of bracket t dt. Now we will break this integral. Integral 1 to 2, 2 to 3, 3 to 4 and so on and so forth. And that is equal to integral 1 to 2. The function is same. Plus integral 2 to 3 plus integral 3 to 4, so on and so forth. Now in the interval 1 to 2, bracket t is a lower one, that is 1. So it will be 7 to the power of 1. In the interval 2 to 3, bracket t is 2, it is 7 square. In the interval 3 to 4, bracket t is 3, it is 1 by 7 cube. So that's what we have 1 by 7, 1 by 7 square, 1 by 7 cube, so on and so forth. Now these constants 1 by 7, 1 by 7 square, 1 by 7 cube, we will take out. 1 by 7 into integral 1 to 2, 1 by t square dt plus 1 by 7 square integral 2 to 3, 1 by t square dt plus 1 by 7 cube integral 3 to 4, 1 by t square dt. Now the integral of 1 by t square is minus 1 by t in all these things, and put the appropriate limits. And that is equal to 1 by 7 minus 1 by t 1 to 2 plus 1 by 7 square minus 1 by t 2 to 3 plus 1 by 7 cube minus 1 by t to be evaluated between the limits 3 to 4 plus so on and so forth. Now when you evaluate minus 1 by t, it will be 1 by the lower limit 1 by 1 minus 1 by the upper limit 2. We have taken care of this minus. So lower minus upper we will do because of the minus. So that is equal to 1 by 7, 1 by 1 minus 1 by 2 plus 1 by 7 square, 1 by 2 minus 1 by 3 plus 1 by 7 cube, 1 by 3 minus 1 by 4 plus so on and so forth. We continue in the next slide. So that's what we have done so far. Now collect all positive terms, that is 1 by 7 plus 1 by 7 square into 1 by 2 plus 1 by 7 cube into 1 by 3, so on and so forth. Collect the positive terms. Right. Then collect all the negative terms and put a minus sign before that, and minus in brackets 1 by 2 into 1 by 7 plus 1 by 3 into 1 by 7 square plus 1 by 4 into 1 by 7 cube. So that's what we have written. Now recall, this is very familiar expansion. So recall log of 1 minus x to the base e, and we have the Maclaurin's expansion, that is minus x square by 2 minus x cube by 3 minus so on and so forth, valid in minus 1 less than or equal to x less than 1. Yes. And in this, put x is equal to 1 by 7. Then you will get log of 1 minus 1 by 7 to the base e is equal to minus 1 by 7 minus 1 by 2 into 1 by 7 square minus 1 by 3 into 1 by 7 cube minus so on and so forth. But we have all positive terms. Therefore, 1 by 7 plus 1 by 2 into 1 by 7 square plus 1 by 3 into 1 by 7 cube plus so on and so forth is minus log of 6 by 7 to the base e. Go back and substitute for this log of minus log of 6 by 7. Now look at this one, and it's also looking something related to logarithm of 1 minus x only. So we multiply and divide by 7. So I'll write minus 7 into 1 by 2 into 1 by 7 becomes 1 by 7 square plus 1 by 3 into 1 by 7 cube plus 1 by 4 into 1 by 7 to the power of 4. So this is what? This is a truncated portion of this logarithm. What is this one? In this the bracket, what is written in the bracket is same as this except for 1 by 7. So from this we write, so the first term is as it is. For the second one, we come here and see 1 by 2 into 1 by 7 square plus 1 by 3 into 1 by 7 cube plus so on so forth is minus log of 6 by 7 to the base e minus 1 by 7. So minus 7 into this one you substitute for the bracket one. So minus 7 into minus of log of 6 by 7 minus 1 by 7. Take the minus inside, then you will get minus log of 6 by 7 to the base e plus 7 times log of 6 by 7 to the base e minus 7 plus 7 into 1 by 7 is plus 1. So it is 1 plus 6 log of 6 by 7 to the base e. That is your answer. And let's look at our options. Our answer appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the problem which is related to the definite integral involving greatest integer function. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We will now discuss the solution of a problem from the section Coordinate Geometry. The problem is related to the concepts of a circle. This question has appeared in the Joint Entrance Examination Main held on 27th June 2022 in the second shift. The given question is, let a circle C of radius 5 lie below the x-axis. The line L1 given by 4x plus 3y plus 2 is equal to 0 passes through the center capital P of the circle C and intersects the line L2 given by 3x minus 4y minus 11 is equal to 0 at Q. The line L2 touches C at the point Q, then the distance of the point P from the line 5x minus 12y plus 51 is equal to 0 is, we have a circle C of radius 5, and it is given that this circle C lies below the x-axis. We are given a line L1 and it passes through the center capital P of the circle C, and L1 intersects the line L2 at Q, and L2 touches C at the point Q. Then required to find the distance of the point P, that is the center of the circle C, from another line 5x minus 12y plus 51 is equal to 0. That is the given question to us. Let's now discuss the solution of the problem in detail. We have a circle C of radius 5 that lies below the x-axis with the center at P. That is the circle C with the center at P and radius 5. We are given the line L2 given by 3x minus 4y minus 11 is equal to 0 touches C at the point Q. There is a line L2 that touches the circle C at the point Q. It is further given that the line L1 given by 4x plus 3y plus 2 is equal to 0 passes through P and intersects the line L2 at Q. We have a line L1 passes through center P and intersects L2 at Q. That means L2 is a tangent to the circle C at Q, and L1 is a line passing through P intersects L2 at Q. That means L1 and L2 are perpendicular to each other. Agreed. These are some of the observations what we have made. First of all, we find what are the coordinates of Q. So, solving, and L1 and L2 are intersecting at this point Q. So, take these two equations, L1 equation and L2 equation, and solve for x and y. We get the coordinates of Q. So, solving the above two equations, we get x is equal to 1 and y is equal to minus 2. Therefore, the coordinates of Q we have obtained, and that is 1 comma minus 2. So, what is our problem? Our problem is we have to find the coordinates of the center P of the circle C. Then if you get that one, then its a distance from this line 5x minus 12y plus 51 is equal to 0 can be found very easily. So our target is to find the coordinates of P. That we will do in the next slide. So Q, the coordinates of Q have written here 1 comma minus 2. We move to the next slide, and our concern is to find the distance of P from this line. So that is what we have done so far, and we have Q, the coordinates of Q are given by 1 comma minus 2. Let the coordinates of the center P be x comma y. So we want to find the values of x and y. Note that y will be minus 1/3 of 4x plus 2. Minus 1/3 multiplied by 4x plus 2. Why? Because P lies on L1. The equation of the L1 is 4x plus 3y plus 2. And when you solve for y, we will get this one. And x comma y are the coordinates of the point P. Therefore, the y coordinate must be this one. Agreed. Now, take this PQ length. PQ is what? The radius, that is 5. So now, PQ is equal to radius is equal to 5. Squaring on both sides, PQ square is equal to 25. The PQ square, the distance formula you use, because the coordinates of P are x comma y, the coordinates of Q are 1 comma minus 2. Use the square of the distance formula. So that will be x minus 1 whole square plus y plus 2 whole square, that is the square of the distance of PQ, that is equal to 25. Now expand this, simplify. So if you simplify, x minus 1 whole square plus, for y we write down minus 1 by 3 into 4x plus 2 whole square is equal to 25. We simplify in the bracket, and we get x minus 1 whole square plus 16 by 9 into x minus 1 whole square is equal to 25. When you add, it will be 25 by 9 into x minus 1 whole square is equal to 25. Cancel 25 on both sides, you will get x minus 1 whole square is equal to 9. So taking the square root, we get x minus 1 is equal to plus or minus 3. And this will imply x is equal to 4. When it is plus 3, it is 4. When it is minus 3, it is minus 2. So x is equal to 4 or x is equal to minus 2. So if x is equal to 4, what is the ordinate? So the ordinate y is, if x is equal to 4, then y is equal to minus 1/3 4x plus 2. In that x is equal to 4, you substitute, simplify, you will get minus 6. And if x is equal to minus 2, then y will be, and put it in the value of y, for x is equal to minus 2, you will get 2. So the coordinates of P are, now P is equal to, the coordinate is x is equal to 4 and y is equal to minus 6. Why we have taken 4 comma minus 6 only? Why not minus 2 comma 2? The reason is that you are given that the circle C lies below the x-axis. Therefore, the y coordinates must be negative. Therefore, y must be minus 6. What y cannot be taken as 2. And P is equal to, the coordinates of P are 4 comma minus 6, because the circle C lies below the x-axis. Now we got the coordinates of P, and the line, we are given a line 5x minus 12y plus 51 is equal to 0. The distance formula, the distance of P from the line can be found. That is the perpendicular distance formula we use and find the answer. Agreed. So to find the distance P from this line, 5x minus 12y plus 51 is equal to 0. And we have P is with the coordinates 4 comma minus 6, and use the perpendicular distance formula. Then that will be equal to modulus of 5 into 4 minus 12 into minus 6 plus 51 by under the square root of 5 square plus minus 12 whole square. And when you simplify, you will get mod of 20 plus 72 plus 51 by 13. Agreed. When you further simplify, you will get 143 by 13. When you cancel the common factor 13, both in the numerator and denominator, we will get the 11. Thus, the distance of the point P, that is the center of the circle C, from the line, a third line, 5x minus 12y plus 51 is equal to 0, is 11. So that is the detailed discussion of the solution of the problem, which is related to the concepts of the circle from the coordinate geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section coordinate geometry. The problem is related to the concepts of parabola. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, if the equation of the parabola whose vertex is at the point 5, 4 and the directrix is 3x plus y minus 29 is equal to 0 is x square plus ay square plus bxy plus cx plus dy plus k is equal to 0, then a plus b plus c plus d plus k is equal to. We are given four options. Option A 575, option B minus 575, option C 576, option D minus 576. And if the equation of the parabola whose vertex is at 5, 4 and the directrix is 3x plus y minus 29 is equal to 0 is given to be x square plus ay square plus bxy plus cx plus dy plus k is equal to 0, then required to find the value of a plus b plus c plus d plus k. That is the given question to us. We now discuss the solution of the problem in detail. We are given a parabola, name it as capital P, with vertex V, with coordinates 5, 4, and a directrix D with equation 3x plus y minus 29 is equal to 0. And it is well known for us that the axis of the parabola passes through the vertex V and its focus we call it as S, and that axis is perpendicular to the directrix D. So let's look at the diagram. This is your parabola. Its axis passes through the vertex V with coordinates 5, 4 and the focus S, and this axis is perpendicular to the directrix D. Right. Now let B h comma k be the foot of the perpendicular from V with coordinates 5, 4 on to the directrix D given by 3x plus y minus 29 is equal to 0. So we will find the foot of the perpendicular BHK. This is your BHK. What is this? BHK is the foot of the perpendicular from the vertex V of the parabola onto the directrix D. So we will now find out h comma k. Now to find the h comma k, we recall a result that we have studied in our geometry class, that is the foot of the perpendicular h comma k from the point x1 y1 to the line ax plus by plus c is equal to 0 is given by h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by a square plus b square. In our case, h comma k is the foot of the perpendicular from the point that is the vertex v 5, 4. So x1 is 5, y1 is 4, and the line in our case is the directrix, which is given by 3x plus y minus 29 is equal to 0. So let's now get into the formula and write down then h minus x1 x1 is 5 by a, the coefficient of x in the directrix, that is 3, and k minus 4, that is y1, by b, the coefficient of y in the directrix, that is 1, is equal to minus a 3 into 5 plus 1 into 4 minus 29 by 3 square plus 1 square. When you simplify this one, including the minus, you will get 1. Then h minus 5 by 3 is equal to 1 will imply h minus 5 is equal to 3 will imply h is equal to 8. And similarly, the k value can be found. So this will imply h is equal to 8 and k is equal to 5. Therefore, the coordinates of B are given by 8, 5. So the BHK is none other than B8, 5. So now with this much of information, you have to find the equation of this parabola in this form and find out the values of a, b, c, d, k and sum it up, then you will get your answer. So our concern is to obtain the equation of the parabola with this much of data. So with this data, we have found b 8, 5, the foot of the perpendicular from the vertex. Agreed. Further, it is known the vertex V is the midpoint of the line joining the focus S and the foot of the perpendicular B 8, 5. So use the midpoint formula. Let to find the coordinates of S, let A, B be the coordinates of the focus S. Then use the midpoint formula. A plus 8 by 2 is equal to 5. B plus 5 by 2 is equal to 4. So you will get A plus 8 by 2, B plus 5 by 2 is equal to 5, 4. So A plus 8 by 2 is equal to 5 will give you A is equal to 2. Similarly, the B value can be found out and B is equal to 3. So the coordinates of S have come. So S is equal to, the coordinates of S is 2, 3. Let us put it here, 2, 3. We continue in the next slide. Agreed. That's the diagram. Now recall. We now recall the definition of the parabola. It says the parabola is the locus of a point P, x, y, which moves such that its distance from the focus S is equal to PM, that is its distance from the directrix D. So it is the locus of a moving point P, x, y, which moves such that PS, the distance, is equal to PM, where PM is the distance of the point P from the directrix. Agreed. So this is PXY, the distance is PS, and its perpendicular distance on the directrix PM. So in the diagram, it shows PM is a little bit longer than PS, but it is equal. And anyway, you have to, therefore PS is equal to PM, squaring on both sides, PS square is equal to PM square. So PS square is x minus 2 whole square plus y minus 3 whole square. And PM is the perpendicular distance from x, y on 3x plus y minus 29. So this is equal to 3x plus y minus 29 by under the square root of 3 square plus 1 square. That is the perpendicular distance. PM square is this one. So this is PS square. Simplify. So root of 3 square plus 1 square. So if you square it, it is 10 will come in the denominator. So this will be 10 times of x minus 2 whole square, x square minus 4x plus 4 plus y minus 3 whole square, y square minus 6y plus 9 is equal to 3x plus y minus 29 whole square. We will use a plus b plus c whole square formula, and you will get 3x whole square 9x square plus y square plus 29 square, that is 841, and 2ab, that is 2 into 3x into y, 6xy, and 2 into 3x into minus 29 minus 174x, 2 into y into minus 29, that is minus 58y. Simplify. 10x square minus 9x square is x square. 10y square minus y square is 9y square. So likewise, we simplify it, we will get minus 6xy plus 134x minus 2y minus 711. That is the equation of the parabola. So the equation of the parabola is this one, and that is given to be, we are given the equation of the parabola is x square plus ay square plus bxy plus cx plus dy plus k is equal to 0. So on comparing, if you compare, a is equal to 9, b is equal to minus 6, c is equal to 134, d is equal to minus 2, k is equal to minus 711. Now what is that we want? We want a plus b plus c plus d plus k. So add all of them, then it will be 9 minus 6 plus 134 minus 2 minus 711. If you simplify, you will get minus 576. That is the answer, that is what is wanted. Let's look at our options. Our answer minus 576 appears against option D. Therefore, the answer to this question is option D. And that is the detailed discussion of the solution of the question, which is based on the concepts of parabola from the coordinate geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We will now discuss the solution of a problem from the section three-dimensional geometry. The problem is on the concept of shortest distance between two straight lines given in the three-dimensional geometry. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is the shortest distance between the lines x minus 3 by 2 is equal to y minus 2 by 3 is equal to z minus 1 by minus 1 and x plus 3 by 2 is equal to y minus 6 by 1 is equal to z minus 5 by 3 is, we are given four options. Option A, 18 by root 5. Option B, 22 by 3 root 5. Option C, 46 by 3 root 5. Option D, 6 root 3. We are given two straight lines in 3 dimensions, required to find the shortest distance between them. That's our given question. We now discuss the solution of the problem in detail. We have two lines. The first line is this one, and the second line is this one. And the first line passes through the point 3, 2, 1 with direction ratios 2, 3, minus 1. And the point, it passes through the point x1, y1, z1 is equal to 3, 2, 1. Let's call that as the x1, y1, z1. With the direction ratios a1, b1, c1, that's equal to 2, 3, minus 1. Similarly, the second is a straight line passing through the point x2, y2, z2 given by minus 3, 6, 5, and with the direction ratios a2, b2, c2 is equal to 2, 1, 3. So that is about the second line. And we have the formula for the shortest distance. The shortest distance is given by modulus of, it's a quotient. The numerator is a 3 by 3 determinant whose first row is x2 minus x1, y2 minus y1, z2 minus z1. Second row a1, b1, c1. Third row a2, b2, c2 by the denominator under the square root of b1, c2 minus b2, c1 whole square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square. Agreed. Agreed. So let's now compute the numerator, the determinant and the denominator in the next slide. So those are what we have done, and this is the formula for your ready reference I have given here. So the first, let's get into the determinant. The determinant x2 minus x1, y2 minus y1, z2 minus z1, first row, a1, b1, c1, a2, b2, c2, second row and third row respectively. And x2 minus 3, minus 3. And y2 minus y1, 6 minus 2. z2 minus z1, 5 minus 1. Agreed. And a1, b1, c1 is 2, 3, minus 1. a2, b2, c2, 2, 1, 3. So simplify. This is equal to the 3 by 3 determinant. First row minus 6, 4, 4. And the second row, third row remains the same. Now expand this determinant by its first row. It will be minus 6 into 3 3s are 9 plus 1 10 minus 4 into 2 3s are 6 plus 2 plus 4 multiplied by 2 1s are 2 minus 6. So expand by means of the first row. Simplify. You get minus 6 times 10 minus 4 times 8 plus 4 times minus 4. And you simplify all this, you will get minus 108. So that is the determinant value. Now next, the denominator. The denominator is under the square root of b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. Now what are these? These are precisely, if you see this here, b1 c2 b2 c1 means it is the minor of this element, a1 one element, minor of a1 one element whole square. And that means what we have written is 9 plus 1. 9 plus 1. This will be 9 plus 1 whole square. This will be minus 2 minus 6. This will be minus 2 minus 6 whole square. And this will be 2 minus 6. And that will be equal to 9 plus 1 whole square minus 2 minus 6 whole square and 2 minus 6 whole square. Because we are squaring it, it is immaterial, and you take these things as it is and square it. And that will be equal to under the square root of 10 square plus minus 8 square plus minus 4 square. So on simplification, you will get square root of 180, that is 6 root 5. Now, the denominator value we know, the numerator and denominator values we have. So we have the standard, the shortest distance. Shortest distance is equal to the determined by this one. Agreed. That's equal to the numerator. Mod of the numerator is minus 108 by the denominator is 6 root 5. On cancellation, you will get 18 by root 5. Let's look at our options. Our answer 18 by root 5 for the shortest distance appears against option A. Therefore, the answer for this question is option A. That is the detailed discussion of the solution of the problem on the shortest distance between two skew lines in three-dimensional geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem from the section Vector Algebra. The given question is about the vectors of the diagonals of a given parallelogram. This question has appeared in the Joint Entrance Examination Main held on 27th June 2022 in the second shift. The given question is, let A and B be the vectors along the diagonals of a parallelogram having area 2 root 2. Let the angle between A and B be acute. Mod A, length of the vector A is equal to 1, and mod of A dot B is equal to mod of A cross B if C is a vector given by 2 root 2 multiplied by A cross B minus 2B, then an angle between B and C is, we are given 4 options. Option A, pi by 4. Option B, minus pi by 4. Option C, 5 pi by 6. Option D, 3 pi by 4. Okay, we have a parallelogram and its area is 2 root 2, and these vectors A and B are along the diagonals of this parallelogram, and the angle between A and B is acute, and the length of the vector A is equal to 1, mod of A is 1, and mod of A dot B is equal to mod of A cross B. If C is a vector given by 2 root 2 multiplied by A cross B minus 2B, then required to find the angle between B and this vector C. And then you have to find an angle between B and C. That means you have to choose an angle from these 4 options. Agreed. That is the given question to us. We now discuss the solution of the problem in detail. We have a parallelogram P with area 2 root 2. This is the parallelogram P whose area is 2 root 2. Given A and B are the vectors along the diagonals of P and the angle between A and B is acute. This is your A along one diagonal, P, the vector B, along the other diagonal. And you are given the angle between A and B is acute, the angle between A and B is theta, and theta is acute. Agreed. Further, we are given mod of A is 1 and mod of A dot B is equal to mod of A cross B. Agreed. Now, we use this fact. The area of the parallelogram is 2 root 2. The formula for the area of the parallelogram is half into modulus of the cross product of the vectors along the diagonals. That is 1 by 2 mod of A cross B. Then this will imply mod of A cross B is equal to, send this 2 to that side, 4 root 2. Let's call this relation as 1. And mod of A cross B, that is mod A into mod B into sine theta, is equal to 4 root 2. One may ask a question, sir, there is a modulus, mod sine theta you have to write. Yes, you are right. But theta is given to be acute, therefore mod sine theta is same as sine theta. Agreed. And mod of A is given to be 1, so substitute, that is equal to, where theta is the angle between A and B, which we have already shown in the figure. So mod A is 1, therefore mod B sine theta is equal to 4 root 2. And that is the relation 2, second relation. We use the other fact, that is modulus of A dot B is equal to modulus of A cross B. And this will be mod A into mod B into cos theta is equal to mod A into mod B into sine theta. Modulus for cos theta and sine theta we have not kept because theta is acute. Mod cos theta is same as cos theta, mod sine theta is same as sine theta. Agreed. So cancellations take place and we will get sine theta by cos theta is equal to 1, that is tan theta is equal to 1. That is because theta is acute, theta is equal to pi by 4. Agreed. Now from 2, second relation, mod B sine theta is equal to 4 root 2. So mod B sine theta, and theta is pi by 4. Sine theta sine pi by 4 is 1 by root 2. That is mod B into 1 by root 2 is equal to 4 root 2. That will imply modulus of this vector B, the length of the vector B, is equal to 8. That is the relation 3. We continue in the next slide. We want these results. Modulus of A cross B is equal to 4 root 2, that is the relation 1. Mod B is equal to 8, that is the relation 3. And we are given another vector C, which is given as 2 root 2 into A cross B minus 2P. And our goal is to find the angle between B and this vector C. So why not we call the angle between B and C as the angle alpha. Agreed. So we take C, take the dot product with B on both sides. So we'll get to C dot B is equal to 2 root 2 A cross B minus 2B in brackets dot B. Now use the distributula, we'll get 2 root 2 into A cross B dot B minus 2B dot B. Now look at A cross B dot B. What is this? This is a scalar triple product of the vectors A, B, B. In this scalar product, what we see is two vectors are same. And in the case of the scalar triple product, if two vectors are same, then it will be 0. So A cross B dot B is 0. And this will be 2 minus 2 into b dot b is mod b square. Minus 2 dot 2 b dot b is minus 2 into mod b square, length of the b square. Agreed. On the other hand, you take c dot b and write mod c into mod b into cos alpha. Right. Here minus 2 into mod b square. So mod b is 8. Mod b is 8. Minus 2 into 8 square, that is minus 128. So right. Now on the other hand, c dot b is mod c into mod b into cos alpha. There is no modulus here. So cos alpha, just cos alpha. And we have c dot b on the other hand, it is minus 128. Minus 128. And on the mod c into mod b into cos alpha, mod c into mod b is 8. 8 mod c cos alpha. C dot b on the other hand, it is minus 128. So therefore, 8 into mod c cos alpha is equal to minus 128, and mod c into cos alpha is equal to minus 128 by 8, that is minus 16. Call this relation as relation 4. So if we know modulus of c, we will get cos alpha, and thereby the angle alpha can be found out. That's the angle between B and C, that is the alpha, can be found out. So what is our goal? Our goal is to find modulus of C. So say take the C, and modulus of C square is equal to C dot C. Right. And C, for C you write 2 root 2 multiplied by A cross B minus 2B dot the same vector, C dot C. Now multiply 2 root 2 A cross B dot 2 root 2 A cross B is 2 root 2 into 2 root 2 is 8. A cross B dot A cross B is mod A cross B square. And minus into minus plus 2b dot 2b, that is 4, b dot b is mod b square. So what happened for the other two products, like A cross B dot B, that is 0. That is 0. And B dot A cross B, that's also 0. That's also 0. So therefore you get this one. And you know mod of A cross B is 4 root 2, that is 8 into 4 root 2 square plus 4 into mod B square, that is 8 square. And simplify, you will get 2 into 256. So that is your mod C square. So what will be mod C? Mod C will be under the square root of 2 into 256, that is 16 root 2. Agreed. We will go back to relation 4, and from the relation 4, mod C cos alpha is equal to minus 16. Cos alpha is equal to minus 16 by mod C, that is 16 root 2, and when simplified you will get minus 1 by root 2. Let's look at our options. So cos alpha is minus 1 by root 2 only for alpha is equal to 3 pi by 4, but not for any of them, any of the other angles. So cos alpha is equal to minus 1 by root 2. From the options, alpha will be 3 pi by 4. So the answer is option D. So that is the detailed discussion of the solution of the problem from vector algebra, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem which is based on the concepts of local maximum and local minimum of a given function. And this question is from the section Differential Calculus. This question has appeared in the Joint Entrance Examination Main held on 27th June 2022 in the second shift. The given question is, if m and n respectively are the number of local maximum and local minimum points of the function f of x is equal to integral 0 to x square of the function t square minus 5t plus 4 whole by 2 plus e power t dt, then the ordered pair m comma n is equal to, we are given 4 options. Option A 3 comma 2, option B 2 comma 3, option C 2 comma 2, option D 3 comma 4. We are given a function f of x defined like this, and it is given m and n are respectively the number of local maximum and local minimum points of this function. Then required to find the ordered pair m comma n is equal to. That is the given question to us. We now discuss the solution of the problem in detail. We have the given function f of x is equal to integral 0 to x square of the function t square minus 5t plus 4 by 2 plus e power t with respect to t. Note down the limits of the integral are functions of x. The upper limit function is x square, the lower limit function is 0. And now let us suppose g of x is equal to x square minus 5x plus 4 by 2 plus e power x. Who is g of x? The integrand. Then your given function f of x is integral 0 to x square g of t dt. To talk about the local maximum and local minimum points of a function, we require to differentiate the function f of x. That means we have to find out the first derivative of f of x. To differentiate this one, we use Newton-Leibniz formula. Why we use this formula? Because these are the limits of the integral are not constants, are not numbers, but instead they are functions of x. So we use such a formula. So we recall Leibniz theorem, or in other words called Newton-Leibniz formula, and that will be d by dx of integral phi x to psi x of ft dt is equal to f of the upper function psi of x multiplied by the derivative of upper function minus f of the lower function phi of x multiplied by the derivative of the lower function. Here the upper function is x square, the lower function is 0. So we will get by Newton-Leibniz formula f prime x is equal to g of the upper function x square into derivative of x square minus g of the lower function is 0 multiplied by the derivative of the 0. So the whole thing is 0. d by dx is of 0 is 0. So this will be g of x square is x square whole square minus 5x square plus 4 by 2 plus e power x square. So this is what we get, and this one is 0. And d by dx of x square is 2x. When multiplied, you will get a 2x in the numerator, x power 4 minus 5x square plus 4 by 2 plus e power x square. We factorize the numerator, and that is 2x into x square minus 1 into x square minus 4 by the denominator as it is. Agreed. We further write down its product as factors. So that will be equal to 2x into x minus 1 into x plus 1, x minus 2 into x plus 2 by the denominator as it is. So now if we put f prime x is equal to 0, we get the critical points. So the critical points are given by f prime x is equal to 0, then x will be equal to -2, -1, 1 and 0, 2. So -2, -1, 0, 1, 2. So these are the 5 critical points. We got it. We continue the discussion in the next slide. Yeah, here is your derivative, first derivative as the product of the factors. And note down the denominator is always positive. Is always positive. It is not equal to 0 and it is always positive. That means 2 plus e power x square is greater than 0 for all x belongs to the real numbers. Agreed. So that is the real number line, minus infinity to plus infinity, and the critical points are plotted here. Agreed. Now to talk about local maximum, local minimum, one method is what is the sign of f prime x, and accordingly we talk about the increasing and decreasing nature of the function f of x in that interval. So now we take a interval in the first column, a convenient point x naught in this interval, and the factors are x minus 2 into x minus 1 into 2x into x plus 1 into x plus 2. Then the product will be f prime x. Then it's a sign we will get. Depending on this sign, we write down fx is increasing or decreasing. Agreed. And we need not worry about the denominator. Denominator is always positive. Therefore, there is no need of considering that one as far as the sign is concerned. Agreed. Interval. The first interval is from left minus infinity to minus 2. So here minus infinity to minus 2. Take a convenient point minus 2.5. So if you take x naught is minus 2.5, minus 2.5 minus 2 is negative, minus 2.5 minus 1 is negative, 2 into minus 2.5 is negative, minus 2.5 plus 1 is negative, minus 2.5 plus 2 is negative. Thus, all the 5 factors are negative. 5 negatives multiplied will give you negative. So f prime x is negative. When f prime x is negative, then fx is decreasing in this interval, in the interval minus infinity to minus 2. So right, minus infinity to minus 2. The point, some convenient point, I have taken minus 2.5, and as I discussed, this factor is negative, 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 negative. All the 5 factors are negative. The product of 5 factors, then that means 5 negatives will be negative. F prime x is negative. Therefore, fx is decreasing. Let's get it. So minus infinity to minus 2. In this interval, it is negative, and fx is decreasing. Agreed? Agreed. Next, go to the next interval. Minus 2 to minus 1. Minus 2 to minus 1. Minus 2 to minus 1, the convenient point we have taken is minus 1.5. Minus 1.5 minus 2 negative, minus 1.5 minus 1 negative, 2 into minus 1.5 negative, minus 1.5 plus 1 is negative, minus 1.5 plus 2 is positive. So what happened? 4 negatives, 1 positive. 4 negatives when multiplied will be positive. F prime x is positive. Therefore, fx is increasing. So in the interval minus 2 to minus 1, what is happening? The sign of f prime x is positive. That is positive. Therefore, it is increasing in this interval. And next, minus 1 to 0, the convenient point what we have taken is minus 0.5, and we have discussed, and we got 3 negatives and 2 positives, and it will be negative. 3 negatives means negative. So f prime x is negative. So for fx is decreasing. Therefore, minus 1 to 0, it is negative in this interval, and it is decreasing. It is decreasing. In 0 to 1, we take the convenient point 0.5 and discuss, and then we get 2 negatives and 3 positives. and two negatives multiplied positive, therefore fx is increasing. So it's positive and it is increasing. And 1 to 2, the convenient point is 1.5, we get 1 negative and 4 positives, then it will be negative, f prime x is negative, fx is decreasing. So here it is negative and it is decreasing. Right. In 2 to infinity, obviously 2 to infinity, if you take a point greater than 2.5, and in every every factor the sign will be positive. So 2 to infinity, 2.5 minus 2 positive, 2.5 minus 1 positive, 2 into 2.5 positive, 2.5 plus 1 positive, 2.5 plus 2 positive. So all are positive. When multiplied it is positive. F prime x is positive, therefore fx is increasing. It is positive, and it is increasing. Agreed. So that is the status. And now it's very easy to say how many local maximum points are there, how many local minimum points are there. So we see this fx attains local maximum at -1 and 1. This is -1 and 1. So, and small m is the number of local maximum points. So m is equal to 2. And the local minimum is attained at x is equal to -2, 0, plus 2. So therefore n is equal to number of local minimum points is 3. And required to find the ordered pair m comma n, that will be equal to 2 comma 3. So let's get into the options. In the options, our answer 2 comma 3 appears against option B. Therefore the answer for this question is option B. So that is the detailed discussion of the solution of a problem which is based on the concepts of local maximum and local minimum of a given function, and the question is from the section differential calculus. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem which is based on the area of a given region, and this question is from the integral calculus. This question has appeared in the joint entrance exam main held on 27th June 2022 in the second shift. The given question is, if the area of the region, the set consisting of ordered pairs x comma y, such that x to the power of 2 by 3 plus y to the power of 2 by 3 is less than or equal to 1, and x plus y greater than or equal to 0 and y greater than or equal to 0 is capital A, then 256 times A by pi is equal to. So we are given this region and we have to find the area of this region, that is capital A, then required to find the value of 256 times A by pi. So we find the area capital A of this given region and required to find 256a by pi. That's the given question to us. Let's now discuss the solution of the problem in detail. So let us first of all get familiarized by this curve. The equation x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to 1. This curve, this represents a continuous closed curve. It may be seen that it is symmetrical about both the axes. So if you substitute a minus x for x, this remains same, and substitute minus y for y, this equation remains the same. Therefore, it is symmetrical about both the axes. This intersects the x-axis at plus or minus 1 comma 0 and the y-axis 0 plus or minus 1. The y-axis at the points 0 comma plus or minus 1. And this curve is famously known as asteroid. This curve is known as asteroid and is shown in the diagram. This is the one, and I will show you in a magnified fashion. So this is the curve. Agreed. Now let's move to the next slide. Now the region, what is given to us, the set of all ordered pairs x comma y such that x to the power of 2/3 plus y to the power of 2/3 less than or equal to 1. So this will give you all points that lie on the asteroid and inside the asteroid, comma means and x plus y greater than or equal to 0. That means y is equal to minus x. Y greater than or equal to minus x means take the line y is equal to minus x, and all those points that lie above the line y is equal to minus x intersect with all the points that lie inside and on the asteroid. Not only that, and y greater than or equal to 0. That means all points that lie above the x-axis, on the x-axis and above the x-axis, and intersection of all these three is the region, and it is shown in the figure. Let's get into the picture. So that's our asteroid. All points that lie inside and on means here. So let's take y is equal to minus x. This is y is equal to minus x. And x plus y greater than or equal to 0 means y greater than or equal to minus x. That means all points lie above this line. And common to all points that lie inside and on the asteroid. So what is common? This portion, and this portion. But now y greater than or equal to 0. That means all points that lie on the x-axis and above the x-axis and common to all the three. Then common to all the three will be this portion and this portion. Now it is shown here. This is the region, shown with a blue horizontal lines, shaded by the blue horizontal lines, and this portion shaded by the red vertical lines. So this portion. So this portion plus this portion. You can see it in a magnified way. So this is the portion. So this one. So the area, the region is this one. The area of this one you have to find. Agreed. Now, A is equal to area of the above region. That is equal to area A prime of the region with the horizontal blue bars. So this one, horizontal blue bars. And plus the area A double prime of the region with vertical red bars. These are the vertical red bars. Agreed. Now, because of the symmetry, the area of this one, that is the area of A prime of the region with horizontal blue bars, this one is same as this corresponding portion in the second quadrant. They are equal, and this line bifurcates, bisects this one and makes equal areas. So this A double prime is half of this one, which is half of A prime. So notice that A double prime is half of A prime, since the curve is symmetrical about y is equal to minus x. Agreed. So therefore A is equal to A prime plus A double prime is half of A prime, that is equal to 3 by 2 times of A prime, and A prime means the region with the horizontal blue bars. So for that we have written 3 by 2 integral 0 to 1 y dx. With the horizontal strips we integrated. So integral x varies from 0 to 1 and they are going like that. So y dx. And what is y? Take the equation of the asteroid and solve for y. So take the equation and solve for y. You will get 1 minus x to the power of 2/3 whole to the power of 3 by 2. So substitute here 3 by 2 integral 0 to 1 minus x to the power of 2/3 whole to the power of 3 by 2 dx. To evaluate this integral, we substitute x is equal to sine cube theta, then differentiating dx is equal to 3 sine square theta cos theta d theta. Because this is a definite integral, the limits will also change. Now, when x is equal to 0, theta is also equal to 0. When x is 1, sine cube theta is 1 and theta will be pi by 2. So the integral 0 to 1 will change to integral 0 to pi by 2. So the area A is equal to 3 by 2 times integral 0 to pi by 2, 1 minus x is sine cube theta, x to the power of 2 by 3 is sine square theta. So 1 minus sine square theta whole to the power of 3 by 2 into dx is 3 sine square theta cos theta d theta. 1 minus sine square theta is cos square theta. Cos square theta to the power of 3 by 2 is cos cube theta, and this will be equal to 3 sine square theta cos to the power of 4 theta. So that will be equal to, and that 3 has come out, 9 by 2 into integral 0 to pi by 2 sine square theta into cos to the power of 4 theta d theta. We recall this is a integral. We know a formula for that. When m and n are both even positive integers, 2 and 4 are even positive integers, then the integral 0 to pi by 2 sine to the power of m theta cos to the power of n theta d theta is equal to, first take this 2 means 2 minus 1 by 2 plus 4, that means 1 by 6, then come to 4 minus 1 by 6 minus 2, 4 minus 1, that is 3 by 4, from 3 subtract 2, 1 by 4 minus 2, 2. So that's what it says. This is equal to 9 by 2 into 1 by 2 minus 1. This is power 2 minus 1 by 2 plus 4, 6. So take the 6 as your starting point. Go to 4. 4 minus 1, 3 by 6. From 6 subtract 2, 4. From 3 subtract 2, 1. Then from 4 subtract 2, 2 into pi by 2. So this is the formula which we have executed here, and when simplified it will be 9 pi by 64. Thus we got the area capital A. Required to find 256 times A by pi, that is 256 by pi into A, that is 9 pi by 64. Pi cancels, 64 4s are, 4 9s are 36. So the answer to this question is 36. That is the detailed discussion of the solution of the problem, which is based on computing the area of a given region from the section Integral Calculus. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem on the concepts of circle, and this is the second question in this question paper, and this question is from the coordinate geometry, and this question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is the set of values of k for which the circle given by C, whose equation is 4x square plus 4y square minus 12x plus 8y plus k is equal to 0, lies inside the fourth quadrant, and the point with coordinates 1 comma minus 1 by 3 lies on or inside the circle C is, we are given four options. Option A, an empty set. Option B, the semi-closed interval 6 comma 65 by 9 closed at the right end. Option C, the semi-closed interval 80 by 9 comma 10 closed at left end. Option D, the semi-closed interval 9 comma 92 by 9 closed at right end. We are given a circle C whose equation is this one, and in this equation we see a k, and we have to find the set of values of k for which this circle C lies inside the fourth quadrant. That is the first condition. The second condition is, and the point 1 comma minus 1 by 3 lies on or inside the circle C. With these, under these two conditions, what are the values of k? That is to be found out. That is the given question to us. We now discuss the solution of the problem in detail. We have a given circle C given as 4x square plus 4y square minus 12x plus 8y plus k is equal to 0. We put this equation of the circle in the standard form. To do so, divide throughout by 4. The equation of the circle C in the standard form we write it as S is equal to, divide throughout by 4, we get x square plus y square minus 3x plus 2y plus k by 4 is equal to 0. And we can now find the center of the circle and the radius of the circle. And if the standard equation of the circle is given by s is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0, then the center is given by minus g comma minus f, and the radius is given by under the square root of g square plus f square minus c. So now in our equation 2g is minus 3, therefore g is equal to minus 3 by 2, and minus g will be 3 by 2. 2f is 2y, f is 1, minus f is minus 1. So the center of the circle is 3 by 2 comma minus 1, and its radius r is given by under the square root of g square 3 by 2 whole square plus f square minus 1 whole square minus c, that is minus k by 4. Now simplify, we'll get under the square root of 13 minus k by 4. Agreed. Now note that we take this first condition. Note that this center of this circle, that is 3 by 2 comma minus 1, obviously lies in the fourth quadrant. Lies in the fourth quadrant. Let us see the demonstration. That's x-axis, y-axis, and your center of the circle, that is 3 by 2 comma minus 1, strictly lies inside the fourth quadrant. And what is the condition? The circle C lies inside the fourth quadrant, that means strictly lies inside the fourth quadrant, if it's the circle's radius must be less than 1. Why? If r, so this center is 3 by 2 units away from the y-axis and 1 unit away from the x-axis, and the circle C to lie strictly inside the fourth quadrant, r must be less than 3 by 2 and r must be less than 1. That means these two conditions will imply only one, that is when r is less than 1. When r is less than 1, it is automatically less than r is less than 3 by 2. So to this circle lies inside the fourth quadrant strictly if the radius of the circle must be less than 1. When it is less than 1, it will be strictly lies inside 1. But what is r? R is under the square root of, this means under the square root of 13 minus k by 4 is strictly less than 1. Squaring on both sides, that will imply 13 minus k less than 4. This will imply k greater than 9. Now with this much of information, let's look at our options. It is one of the clever ways of doing it. Sometimes it is possible in some questions. In this question, it is possible. K greater than 9 is possible, not in option an empty set. K greater than 9 means this is not true. K greater than 9, this is k greater than 6. No. K greater than 9, this is also not true. K greater than 9, the only option that is available for which k greater than 9, by using only one condition. Only one condition. So the only option where k greater than 9 is the semi-closed interval 9 comma 92 by 9, where it is closed at the right end. So our answer to this question is option D. And mind you, we have not used, there are two conditions given to us, and one condition we have used, and the other condition, this is the point 1 comma minus 1 by 3 lies inside and on the circle C, we have not used. Without using it, we are able to say the answer, because the answers are given like this. So sometimes this happens. Not always. And however, I want to discuss a detailed solution of this question in the next slides. So we go for a detailed solution for this question. So that is your question, and that is our argument. So the circle C, then we have put the circle C in the standard form, then we have the center, then we have the radius. Agreed. Then we have used one condition, that is the center C lies inside the fourth quadrant, and we got the answer k greater than 9. Let's call this as the condition, that is the relation 1. Agreed. Now continue. We continue. The radius of the circle must be positive, or at least or non-negative. So now r, that is under the square root of 13 minus k by 4, is greater than or equal to 4. This will give you k less than or equal to 13. This is another relation, that is the second relation. We continue in the next slide. We go for the other condition. What is the other condition? The other condition is that this point 1 comma minus 1 by 3 lies inside and on the circle C. And we have already seen from the last slide two conditions, condition 1 and condition 2. Now we have the standard equation of the circle. Now we use this condition. So given the point 1 comma minus 1 by 3 lies on or inside the circle C. That means take this point and substitute in S, and lies on means is equal to 0. Inside means less than 0. So that means we have S1. S1 means the value of S at x1, y1. The x1, y1 is 1 comma minus 1 by 3 is less than 0 inside the circle C, is equal to 0 on the circle C. So S1 is less than or equal to 0. So in S, substitute x is equal to 1, y is equal to minus 1 by 3 in this, and simplify, we'll get 9k minus 92 by 4 is less than or equal to 0. This will give rise to k less than or equal to 92 by 9. That is the relation 3. So we have these three relations, 1, 2, 3, k less than or equal to 13, and k greater than 9, and k less than or equal to 92 by 9, and means intersection. K less than or equal to 13 means, all k less than or equal to 13 means the interval minus infinity to 13, semi-closed interval, minus infinity to 13, and k less than or equal to 92 by 9 means a semi-closed interval minus infinity to 92 by 9, and means intersection. When you take the intersection, smaller of these two will come, that is minus infinity to 92 by 9, and closed at 92 by 9 end. And this will imply k greater than 9, and between these two, smaller of these two, k less than or equal to 92 by 9. This will give rise to 9 less than k less than or equal to 92 by 9. So that means this is k belongs to the semi-closed interval 9 comma 92 by 9, closed at right end. And let's look at our options. Our answer is appearing against option D. Therefore, our answer is option D. So that is the detailed discussion of the solution of the problem on the concepts of the circle from the coordinate geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. now discuss the solution of a problem related to a line and a plane from the section three-dimensional geometry. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let the foot of the perpendicular from the point 1, 2, 4 on the line x plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3 be p. Then the distance of p from the plane 3x plus 4y plus 12z plus 23 is equal to 0 is, we are given four options. Option A 5, option B 50 by 3, option C 4, option D 63 by 13. And we are given a line x plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3. And the foot of the perpendicular from the point 1, 2, 4 on this line is given to be the point P. Required to find the distance of this point P from this plane 3x plus 4y plus 12z plus 23 is equal to 0. That is the given question to us. We now discuss the solution of the problem in detail. We have the given line denoted by L given as x plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3. It is a line, straight line in 3 dimensions with the direction cosines 4, 2, 3 and passing through the point minus 2, 1, minus 1. The direction ratios of this line L are 4, 2, 3. Agreed. Given P is the foot of the perpendicular from this point 1, 2, 4 on the line L. Agreed. Now we take the line and the coordinates of any point on this line L can be obtained as follows. Take the line, equate each ratio to lambda. X plus 2 by 4 is equal to y minus 1 by 2 is equal to z plus 1 by 3 is equal to lambda. This will give rise to x is equal to 4 lambda minus 2, y is equal to 2 lambda plus 1, z is equal to 3 lambda minus 1. So any point on this line L will have these coordinates. And since P is the foot of the perpendicular from that point on L, that means P is a point on L. Therefore, the coordinates of P are also given by, 4 lambda minus 2, 2 lambda plus 1, 3 lambda minus 1 for some lambda, for some lambda, because P is any point on L. P is the foot of the perpendicular from this point 1 to 4 on this line L, and P is any point. P is a point on L. Therefore, P will have these coordinates for some lambda. Agreed. Now we know A is 1 to 4 and P is 4 lambda minus 2, 2 lambda plus 1, 3 lambda minus 1. The direction cosines of the AP can be found out. And the direction ratios of the line joining 2 points x1, y1, z1, x2, y2, z2 are x2 minus x1, y2 minus y1, z2 minus z1. So the direction ratios of AP are given by 4 lambda minus 2 minus 1, comma 2 lambda plus 1 minus 2, 3 lambda minus 1 minus 4. That is 4 lambda minus 3, 2 lambda minus 1, comma 3 lambda minus 5. These are the direction ratios of AP. Great. Now we have this L, the direction ratios are 4 to 3. We have AP, the direction ratios are 4 lambda minus 3, 2 lambda minus 1, 3 lambda minus 4, and they are perpendicular to each other. Because P is the foot of the perpendicular from A on L. Therefore, this line L and AP are perpendicular. Therefore, the direction ratios are to be multiplied like this. So, if two lines with direction ratios A1, B1, C1 and A2, B2, C2 are perpendicular, then A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So, apply this. So, since AP is perpendicular to L, 4 times 4 lambda minus 3 plus 2 times 2 lambda minus 1 plus 3 times 3 lambda minus 5 is equal to 0. Multiply and simplify, you will get it 29 lambda is equal to 29, lambda is equal to 1. Now with this value of lambda, we can find out the coordinates of P. So the coordinates of P are here, and put lambda is equal to 1 in this, then you will get the coordinates of P. So the coordinates of the point P, which is the foot of the perpendicular, are given by those coordinates 4 lambda minus 2, comma 2 lambda plus 1, comma 3 lambda minus 1 to be evaluated at lambda is equal to 1. Put lambda is equal to 1 in this, then you will get 2, 3, 2. So the P coordinates have come. Now the P coordinates have come and required to find the distance of P from this plane. So the plane is known and the coordinates of P are known. So the perpendicular distance formula from a point onto the plane is known. So substitute and compute that, take that formula and compute that perpendicular distance. We do it in the next slide. We have the coordinates of the point P are 2, 3, 2. Now the distance of 2, 3, 2, which is the point P, from this plane 3x plus 4y plus 12z plus 23 is equal to 0. We recall the formula. The distance of the point x1, y1, z1 from the plane ax plus by plus cz plus d is equal to 0 is equal to modulus of ax1 plus by1 plus cz1 plus d, mod closed, by under the square root of a square plus b square plus c square. So that will be given here as is equal to modulus of 3 into 2 plus 4 into 3 plus 12 into 2 plus 23 modulus over by under the square root of 3 square plus 4 square plus 12 square. So multiply. So you will get mod of 6 plus 12 plus 24 plus 23 by under the square root of, this is 169, under the square root of 169 is 13, and that is equal to, the numerator is 65 by the denominator is 13. So when cancellation we do it, then we get 5. Thus the perpendicular distance of the point P from this plane 3x plus 4y plus 12z plus 23 is equal to 0 is 5. So let's look at our options. Our answer 5 appears against option A. Therefore, the answer to this question is option A. So that is the detailed discussion of the solution of the problem which is related to a line and a plane in the three-dimensional geometry. So I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you. We now discuss the solution of a problem based on the concepts of probability from the section Statistics and Probability. This question has appeared in the Joint Entrance Examination Main held on 27th June 2022 in the second shift. The given question is, let S be a set consisting of E1, E2, etc., E8 be a sample space of a random experiment such that probability of En is equal to n by 36 for every n is equal to 1, 2, 3, etc. up to 8. Then the number of elements in the set consisting of A is a subset of S such that the probability of A greater than or equal to 4 by 5 is, we are given a sample space S consisting of E1. S is a sample space which is S is the set consisting of E1, E2, etc., E8, and it's a sample space of a random experiment, and probability of En is given to be n by 36 for every n is equal to 1, 2 up to 8. Required to find the number of elements in the set consisting of A is a subset of S such that probability of A is greater than or equal to 4 by 5. That's our given question. We now discuss the solution of the problem in detail. We are given S is a set consisting of E1, E2, etc., E8, and it is the sample space of a random experiment, and probability of En is given to be n by 36 for all n is equal to 1, 2 up to 8. Let capital B is equal to the set consisting of A, subset of A is a subset of S such that probability of A greater than or equal to 4 by 5. Required to find the order of B. So the number of elements in this set, that is required to find the order of B. Now note down, for any A belongs to S, it satisfies probability of A greater than or equal to 4 by 5. For any A which is a subset of S, that means A belongs to B, probability of A is equal to sigma probability of EI, where the summation runs on those I for which E suffix I belongs to A. So probability of A is sigma of probability of EI, the sigma runs on I, that is the summation runs on those I for which EI belongs to A. That is, the probability of A is equal to sigma probability of EI, sigma runs on I, that is equal to sigma running on I of I by 36. Agreed. So that is the probability of A. Now for any A belongs to B, now for any A subset of S, this is the one. For any A belongs to B, it is given probability of A greater than or equal to 4 by 5. So for any A belongs to B, we have probability of A greater than or equal to 4 by 5. And the probability of A means sigma I by 36. So sigma means any possible sum. There is no guarantee that all I is equal to 1, 2, 3 up to 8 will be there in A. A is a subset of S. Sum of them will be there. Any possible sum of the indices coming from the set 1 to 8 by 36, because it is a summation, is greater than or equal to 4 by 5. This any possible sum of 1 to 8, we say alpha, then it will be alpha by 36 is greater than or equal to 4 by 5, where alpha is any possible sum of the indices coming from the set 1 to 8. Agreed. We continue in the next slide. So that's what we have done. Instead of A belongs to A, instead of A belongs to B, we consider A prime, that is the complement of A, and see the probability of A. Now, probability of A bar, yes, complement we have denoted by bar, not by prime. Sometimes we denote by A prime also. Probability of A bar is equal to 1 minus probability of A, and the probability of A is greater than or equal to 4 by 5. Therefore, 1 minus probability of A is less than 1 minus 4 by 5, that is equal to 1 by 5, where this A bar is the complement of A, that is S minus A. So, probability of A bar less than 1 by 5 means any possible sum of missing indices, missing numbers of the set consisting of 1 to 8. Let us say the sum of those missing numbers be beta by 36 is less than 1 by 5. So this means 5 times beta is less than 30. That means 5 into what is beta? The sum of the missing numbers of 1 to 8 less than 36. Less than 36. And this will be easy to verify rather than this one. Now, case 1. Suppose no number of this 1 to 8 is missing. If no number is missing, then the above inequality, this inequality less than 36, is trivially true. That means one subset A is equal to the whole sample space S of S satisfies this condition, probability of A greater than or equal to 4 by 5. Agreed? So, S is a candidate. S belongs to B. So, A belongs to S. A is equal to S belongs to B. That means in B, there is one set, yes, that satisfies this inequality greater than or equal to 4 by 5. So we are counting how many elements are there in B. Okay, we continue and go for case 2. If one number, say n, of 1 to 8 is missing, then by this 5 into the missing number, sum of the missing numbers means only 1, 5n less than 36. Now verify for what values of n 5n is less than 36 out of this 1 to 8. So 1 satisfies, 2 satisfies, 3 satisfies, up to 7 satisfies. That is 5 into 7, 35 less than 36. So up to 1 to 7, up to that it satisfies. If you take n is equal to 8, 5 8s are 40, less than 36 is not true. So therefore, who are those n's? So this holds only for n is equal to 1, 2, 3, 4, 5, 6, 7, but not 8. So that means 7 subsets of subsets A. What are those subsets? A is equal to S minus En. So S minus E1, S minus E2, S minus E3, S minus E7, 7. So they satisfy this condition, probability of A greater than or equal to 4 by 5. So what are we doing? We are traveling from the complement of the set to the set. So 7 subsets. So that means A is equal to S minus En belongs to B this B for n is equal to 1, 2, 3, 4, 5, 6, 7. So it is, we have already seen in the last slide, the whole set S belongs to B. So 1 there. Now it's 7, 1 plus 7. Let's go to the case 3. Case 2, case 3. This is not case 2, case 3. If two numbers, say mn of 1, 2, 3, 8 are missing, then by this 5 times the sum of the missing numbers, that is m plus n less than 36. Right. So for what values of m and n this is satisfied? So this holds only for the ordered pair m comma n, 1 comma 2. So if you take 1 comma 2, 5, 1 comma 2 means 1 plus 2, 3. 5 3s are 15 less than 36. 1 3, 5 4s are 20. 1 4, 5. 5 5s are 1 5. 1 plus 5, 6. 5 6 are 1 6. 1 plus 6, 7. 5 7s are 35. Suppose you take 1 comma 7. 1 comma 7. It will be 5 times 1 plus 7. That is 5 times 8 is 40 less than 36 is not satisfied. Therefore, it will stop. So these are the ordered pairs up to 6. 1 comma 7 is not there. 1 comma 8 doesn't satisfy. Then start with 2. 2 comma 1 we have already seen here. So start with 2 comma 3. 5 5s are. 2 comma 4. 5 6s are. 2 comma 5. 5 7s are. So if you take 2 comma 6, then it will be 2 plus 6, 8. 8 5s are 40. 40 less than 36 is not true. So then go for 3 4. Only that much. You can verify the others will not work. Will not work. So we'll stop there. So how many? So that means 9 subsets. These are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 subsets. That is A is equal to S minus Em comma En for these values of Mn's of S satisfies the condition probability of A greater than or equal to 4 by 5. That means these A is equal to S minus Em comma En belongs to B for these 9 subsets. So therefore 1 plus 7 plus 9. So from here 9 will join here. So 1 plus 7 plus 9 sets will be there in B so far. Okay, let's move to the next case. Case if 3 numbers, say L comma M comma N of 1 to 8 are missing, then 5 times L plus M plus N is less than 36. This holds only for 1 comma 2 comma 3. If you take 1 comma 2 comma 3, 1 comma 2 comma 3, their sum is 6, 5 6 are 30, 30 less than 36. 1 2 3, after that 1 2 4, 1 2 4. It is 7, 5 7s are 35 less than 36. This is also holds good. Suppose you take 1 2 5. 1 to 5, the sum is 8, 5 8s are 40, 40 less than 36 is not work. After that, nothing works, nothing works, nothing works, nothing works. No other triad will work. These are the only 2 triads that will work here. So you can verify, And these are the 2 subsets. A is equal to S minus EL, the set consisting of EL, EM, EN of S satisfies this condition, probability of A greater than or equal to 4 by 5. Therefore, A is equal to S minus the set consisting of EL, EM, EN for these 2. So the two subsets will be there. So the sum will become 1 plus 7 plus 9 plus 2. So that is, and if you want to talk about 4 of them are missing, you take any 4, take their sum, 5 times of that is greater than 36. So therefore it will stop here. So cardinality of B is equal to, that is the n of B, or order of B. Order of B is equal to cardinality. This is the order of the set consisting of A is contained in S such that probability of A greater than or equal to 4 by 5 is 1 plus 7 plus 9 plus 2, that is 19. So the order of B is 19. That is what is wanted. That is the answer for this problem. And that is the detailed discussion of the solution of the problem which has appeared in the examination, coming from the subsection probability. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.